memberships.
Good morning, good afternoon, good evening, everyone. Welcome. I'm going to introduce you all to Frank from the Calico crew. Hi, Frank. How are you?
I'm doing well. How about yourself today, Steve?
I'm doing well. We're supposed to hit triple digits here today. What's going on down in Arizona? What's that?
I had the stream up and it started playing.
Oh.
Terrible echo.
What's your temperature supposed to be down there today?
Oof. I don't know. Unbearable.
Unbearable. Okay.
Actually, only 90. 99.
Okay. I want to thank Rod for gifted memberships and Derek for gifted memberships. Say hi to Maurice and Malfrey. Hey, who else do we have? Zybertech and Eric. Just going to skim some names here. Hey, Bob. Hey, Arthur. Hey, Raj. Okay, so we have Frank here. Frank from the Calico crew. Thank you for coming on. We are going to today finish configuring a Micron here and start a print. But this is my very first install of Calico on any printer. We did the install last week. Here we go. And we still have a few configuration things to do. So, real quick, from your perspective, what is Calico? What's cool about it?
Calico is a community-maintained fork of Clipper where we're willing to integrate all of the plugins and features that aren't quite ready to go into mainline Clipper to give users an easier way to access them and try out the new bleeding edge features and more advanced kinematics, temperature control models, all the fun stuff.
Turn you down just a little bit to get you more in line with where I'm at. Awesome. And when we installed this, we did select the bleeding edge features branch. So we can go through a few of those and kind of check it out. Real quick, Maurice had a birthday last Wednesday. Say happy birthday to Maurice. Okay. What else do we have here? And there's a particular application for some of the stuff that Calico enables. It's off to your right there, huh?
Oh, yeah. The Cocoa Press 2 ships with Calico as the firmware with a lot of customizations and some really cool features on the way.
That's awesome. Okay, let's look real quick before we dive into configuration and stuff. We can go through the Calico documentation, and this link is in the description. A couple other things before we really get going. This is the last stream in this series, so we are giving away another Colony Clacker door kit from LDO. Thanks to LDO for that. And we are giving away a roll of Polymaker filament, as we do every week. So those links are in the description. So anyway, if we go here, documentation is pretty good. So it looks like I feel like I found some gaps in the installation instructions when we did the install, but chatted a little bit with Roger on that. And of course, documentation is always going to be the hardest thing to do on these kind of projects, right? Capturing everything you need to, every scenario that you can. Where is that line? Documentation versus letting people figure out or put the pieces together.
And we got really lucky there. We had a couple community members really step up to come in and just write documentation.
Yeah. So if we go, let's see, overview, it's talking about, start with the features and installation documents. So let's go to features, because I think features is probably a big thing, right? Where is it different from Clipper? This is a lot of copy paste from Clipper.
A lot of it's the same documentation.
Yep.
for the main changes, if you drop the configuration, the Calico additions
there we go. Yeah, we went through this a little bit last week. Some changes to defaults. A big one here that a lot of folks find useful is this non-critical MCU setup, right? So
yeah,
you have
so much nicer than editing your configuration every time you unplug your accelerometer.
Yes, or your display stops working in the middle of a print. You know, it's one of those 12864 display adapters. It runs a little STM chip, and it's a microcontroller that has to be there in order for everything to be happy, but it fails or it times out, and it doesn't matter if it timed out, but your print is done. So this is really handy. Danger options, is that an actual configuration thing? You put that in there?
It is a new section in the configuration that exposes some. Initially, there were a little more dangerous features. We've been going back and revising them, adding safety checks where they were missing. So now most of it is just the really advanced little knobs. If you need a little more control over exactly when synchronization happens between the microcontroller and the host during homing, or little things like that, that's where those changes are going to live.
And if we click on this, we should get some of what those particular things are.
Okay. My favorite there is the autosave includes.
Autosave includes.
If you have multiple files for your configuration, including different files for different sections, you might have found that save config will just error. This lets it update those included files instead of crashing out.
Oh, okay. Neat. Home start delay. Okay. And then one of the big things we're going to be working with today is, where is it? Is it in here? Some of the sensorless homing. There we are. A whole section on sensorless homing changes. More things we can tweak.
Yep. And a lot of these are things that people have been using macros for in Clipper for a long time. Changing your run current before you start homing, or making it home twice to get because the first hit's going to be a little less accurate, but then you back off and you tap again, you're going to get a pretty close precision every run.
Okay.
So that's just automated now.
Awesome. Why don't we get right into that? Let's get the printer homing, and then we will look at, are there any bleeding edge features we should look at before we get the printer homing?
If you want to start enabling the high precision step compressing now, because that requires the microcontroller reflash.
Okay.
We could turn that on, or we could leave that till later because reflashing isn't hard anyway.
Would we need to recalibrate sensorless homing when we change that?
I don't believe that really affects sensorless homing at all.
Okay. So let's go ahead, while it's on here, let's just go ahead and do the sensorless homing configuration then. So I've got way too many windows up. Let me close a bunch because I'm done with some of this. Okay, so here we are. We are running fluid. And I did, between streams, enable the chamber thermistor. So I installed a PT1000 thermistor I have. It's sitting in the little spot at the back of the gantry. And I also, let's get a little shot of this if I can, did find or modeled a solution. Let's see. There we go. You can see, hey, I love it when I get a reasonable shot. So I modeled this little piece here. It goes across, just covers the gap between the A and B steppers, and that just holds all the wires up in there for the thermistor and the stepper wires. It's held on with a screw on each end, and then just has channels for the wires to go up in there. I did want to do something to cover up this monstrosity of connectors on the corner, but it was taking too much time, so I skipped that. Hey Matt, what are you doing? Hey Justin, hey Schlunky, hey Morden. We have inspector. Our inspector's up here. So, okay, so sensorless homing.
Yes.
Let's go and check out our configuration first. Finally broke down and ordered some iOS crimpers to replace my engineer crimpers. Awesome. Link here, printer config, and let's get all the way up here to checking the X stepper. We already have these set up for virtual end stop. Everything should already be set for the Oscar's up here to get a felt ball. Should already be set for that, but the things we need to add in here, if we go to sensorless homing, we can set a home current. And do we want add a delay before homing? What of these are advisable in setting up?
The dwell time, there's a default for that. You shouldn't have to worry about configuring it. The home current, usually it's best to find the lowest possible current that still homes.
Oh, okay.
So if you're running at 1 amp, starting at like 0.6 is usually a good starting place. Just that way, if you crash, it's not going to be crashing hard.
Okay, so if we go in here, this is going to be in the TMC 5160 current 0.6. So what is we're running 0.8 run current. What are these? These steppers are much higher than that. Where's my phone? I don't have my phone. Well, shoot, I don't remember what these are new steppers. These are new steppers.
Is this the LDO kit?
It is a rebuild of the partial kit that I did 2 years ago. However, I did receive things like the live idlers from LDO that are going to be included in the upcoming kit, as well as the steppers. And then I purchased the Leviathan and Nighthawk 36 to match what's going to come in the kit, because the Manta M8P that I was using for some reason failed, and I don't know what the reason is. So I think these are at least 1.6 amp steppers, right? Shoot, I would grab my phone and look at it, but I didn't actually bring my phone even into the room with me. Okay, well, whatever. I'm gonna assume that I can run at least an amp on this. Okay, home current. The dwell time, you said the default is probably okay?
Yeah.
It's not in my pocket.
The home retract distance is that second homing where it'll bump back off, bump again.
Okay.
And then the minimum home distance, if you're right up against the edge of your axes, it does an initial retract before it homes, so that you're not having weird issues with the sensorless triggering.
Now the minimum home distance, does that, if you're at the max, will it just grind for a second? Or does it try to do a home, and if it doesn't move far enough, then it'll
that
move
one
back?
backs off first, and then let me check and make sure which way that goes if you're already at the minimum.
And isn't homing retract distance, isn't that in Clipper?
It is, but it doesn't interact with sensorless.
I know
normally.
okay. I know the recommended Here, let's copy that. I know the recommended configuration for sensorless with Clipper is to disable it. Homing retract distance, and then what is this? Minimum home distance. Minimum for tool head before sensorless homing. If closer than minimum home distance to end stop, it moves away to this distance. So it says if closer to end stop, it moves away from this distance, then homes. If further, it directly homes and retracts. The default is equal to homing retract distance. So we'll just leave it to 5. Yeah, we'll leave it at the default.
That'll work.
So I need to grab this and put it down at Y. What am I doing here? I put that in the wrong spot. That goes there. Doesn't go. I'm getting confused. I am getting confused because there's multiple sections here. Let's get that out of there. Wow, yeah. The way this config file is set up is fine. It's just reading it is, since there's multiple stepper X sections, because of if you're using sensorless homing, which makes sense. I should probably keep that down here. If you're using sensorless homing, oh, and then homing retract distance is here. So we're gonna go 5 there instead. And then the homing current, run current. Oh, so this is run current, but I want this down in the, just to go in line with the, oh, and it already did it. It's already here. So that's already there is, okay. Some of this has already been set up apparently in the config. Oh, I was mentioning earlier that my back is bugging me. I might really have to kick Oscar out of his chair.
Poor Oscar.
It doesn't back up first. It only does it if you don't move far enough. Morden was confirming. Okay, so let's go back here. Stepper Y, and I wanted to move this down to the if sensorless homing section. Oh, which I never uncommented. Five. And then the stepper Y. If, oh, why are there 2 of those? Stepper Y, uncomment if sensorless homing. There's 2 of those. That's why I never uncommented it.
Is one section for sensorless homing
Manta.
on one?
Yep, for Manta, and then Leviathan. Ooh, I recommend someone setting one of these up, go through and delete the sections you're not going to use. And then the home current 0.6 needs to be put down. .6, and we're going to change this one to. Okay. I think that is it, right? Save and restart.
Looks about right.
TMC stepper X. Did I mess that up? Did I? TMC stepper X must be specified. What did I mess up? Stepper X.
Get commented out. One
TMC
place.
stepper X.
You've got the home current there, but not the run current.
Run current did, oh, but run current, Oh, did I delete that somewhere? I think I deleted it. All right. I got very confused with that. That's what happened. Let's start, see if that does it. Shows you Sensorless homing on my stock Micron, but I don't like the fact that you can't speed it up. It's possible to control speed of homing.
Yes. And you can actually control the speed of the first homing versus the second homing separately.
Can't you? So homing speed is just a normal configuration. The second homing speed should be as well, right?
It is.
Do you have any recommendations? Huh? Go ahead.
Any recommendations for what?
For the homing speed for Sensorless?
What were we recommending? I think half of the rotation distance is generally what we go with.
So 20? Or is it even lower? That would be 8. Or no. Yeah, it'd be 20 or 16. That seems low. The other thing I need to do while we're thinking about that. So if I look at the printer here, and can I get in here close enough? I left the belts long here for now, and if I physically move the printer to the end, it gets bound up in the pulley on the side. So I need to go ahead and trim those. I'm gonna try to just trim those basically flush.
In the documentation, we recommend 1 full rotation of the stepper every 2 seconds. Which is typically rotation distance divided by 2. Morton is saying with the 5160s, homing speeds of 80 to 100 work much better though.
Really? Just cutting these flush with the edge of the fan, so I still have some.
Elle did such a great job with the design of all these parts. That just looks amazing.
It does. It really does. Did I do it right, Oscar? Did I cut it right? Did I make some noise even remotely resembling the treats bag? Okay, so as we do here, our first, here, let's do this. Take the door off for a bit. I don't have to move it around. Okay, let's see. So I'm gonna home X. See where that's at. It is set right now to 1, so we're probably we may get something, and then we need to see what direction we're going. Okay, so it's too sensitive, but it did try to move in the right direction. So early homing triggered on second home. That's fine. And let's do a Y just to make sure things are moving in the right direction. We don't have to change any direction flags. Hey, Leonard. Hey, Nemo. Must home axis first. Does it need X to home first before Y will home on its own?
It shouldn't. That might be in the homing override, though.
Might be. Well, let's get X. Let's get X's set. Yeah, I got a different error for Y. It says must home axes first. So there must be something. There is, we go to, where is it? Configuration. Is there TMC settings directly in here, or should I go to the Clipper docs?
There are the TMC settings.
Device specific?
Are,
No.
are we looking for the sensorless tuning page?
Yeah.
That's under getting up and running TMC
Getting up
drivers.
and running. TMC drivers. Here we go. So I always have to look this up. Instead of going in, changing a value in the configuration, saving, and trying again, running the set TMC, whatever that
Field.
flag is.
Set TMC field, stepper
Yeah.
equals, field equals.
And right here, this one right here. Value. So that's a value from, huh? That's a value from -64 to 64. -64 is the most sensitive in 63. So I think our value right now is 1. If I remember looking at that correctly, there's stepper Y, stepper X, it's 1. So we're gonna try 2, huh?
Yeah, small changes with 5160s.
Yep. Most of my 5160 printers are either 0 or 1. I don't think I have anything that's gone to a number other than those until now. Or if this goes and grinds, then we're gonna have to change our homing current or speed or something.
Just bump up the current a tiny bit.
So if we go in here and set this, and we're gonna set this to 2. So this is first stepper X. SGT, is that the correct field?
Yes.
And now we can try homing again. Oh, that worked pretty well.
That looked great.
Yeah, we'll leave that right there. So now if we try Y, okay, so that's what it's all in that homing override is where that arrow is coming from. So, which is interesting because you should be able to home them individually, but that's okay. It's configuration stuff we can deal with later. So now we need to change the Y value, and let's see where it is right now. And stepper X, we might as well just change this to 2 right here. And then stepper Y is 1. So I'm just going to save this. I'm not going to save restart. But if we go down here now and change this to 2 as well, change this to Y. Now we'll try homing again. I must home access first. Okay, so we have to, we're gonna run out of Z travel here pretty soon. Now why? It's a little harsh. I mean, the X was a lot smoother, but it worked. If that's a little harsh, should we go a little lower on the current or?
A little higher, probably. Enough to overcome the physical resistance.
Oh, okay. A little higher on the current. So let's go here, here, and we're going to change this to 2, and we're going to go 0.7.
Sounds like a plan.
There we go, 2 and 0.7. So let's go ahead and save and restart this one.
And then try the SGT of 1 again, just to see.
Oh, okay. That's a good call. So let's go back here. 1, because I just set that to 2. So set that to 1. So. Hey, Bob. It did do the double bump. and Y. Oh yeah, good job. Right there.
Awesome.
We're good.
Perfect. It's a delicate balance of figuring out what the right current to home at so that the driver can measure the spike in current when it bumps.
Okay, so let's go in here and change our Y back to 1. Oops. And we will consider that done. So let's save. I'm gonna try to pay attention to what's being hidden on the screen by the various cameras and stuff, Kali. So feel free to remind me if I miss though. Okay, so sensorless homing is set up. So now we need to set up Z, and here right now we know that the there we go. Why are you moving? Oh, because I don't have that one locked. So here's the Revo PZ board. If I tap, see, little taps, it's triggering. So it is functioning. So now we're just going to try a Z home, and I'm gonna tap it manually by hand for this first home. So I think we can just do this. I'm just gonna do a home all and see what happens. Hey, Bill. Thanks for stopping in. Okay.
False.
So,
There.
false, which is fine because the default for these is to be too sensitive. So what I want to do is go out to the E3D documentation because I don't have this memorized. So let's go to E3D online. All the way down at the bottom of the page is their help center, Centre. And Revo support. And then here, Revo support for on PZ Pro. And here will be some preset settings, but there are some firmware configuration we should look at and see how they might or might not apply to Calico. So after all of the mounting and installing, there are some clipper configuration. Clipper config. Oh, so they are suggesting to do, as far as the speeds and stuff, matching this, but there is an activate G code for Z homing. Now, does this work in Z home? So we can change our current?
We can use the home current configuration value in Calico.
And that's all they're doing here is just changing the current as far as the activated G code here. So then they suggest 5 millimeters per second speed, and we'll go and look at a lift speed of 10. So let's go and look how that matches in our configuration here. So we go to Z, and
you do have a pzprobe.config from the Micron firmware. Not sure if you need to look at that one if you're including it.
Good call. Let's see. For stepper Z, we've got a homing speed. Oh, this is just, we would be looking at our probe. But our home current, we can put that in here, right?
Yeah.
Home current. And do you, I think you only, do you have to set this for every
stepper?
Every one, okay. Let's go 0.5, I don't know. What did they say here?
They
all
did
the way down to
0.4.
0.4.
It's really going to be printer to printer specific what you want to use there. So you can see if 4 works, and if not, tweak it.
And then stepper Z1, this here, Z2 and stepper Z3. Okay, and then I don't think, if we come down here, as far as got extruder, got bed, we've got probe. So it is include PZ probe. So all of our probe stuff is going to be over there. So let's save this, close it, and go to PZ probe. And now this is setting up the activate G code. So we can get rid of this. Just comment that out. And our lift speed of 10. So this is already set up for their recommendations. Should be good. That's all,
Yep.
all we should have to change. Let's double check if there's anything else they recommend. I think that's it. And then our presets here. So this little table here is what we may be looking at. And I think it gets progressively less sensitive with each press of the button. So that's what we'll basically do, is try it with one press and then try it with two presses.
Yep. And it goes for least, more, most, and then loops around, and you start getting different configurations for the filtering.
Yep. Nurgle Rot, it is on my GitHub. Believe it or not, I have put that out on my GitHub, as well as every other modification I've done to the micro, except I haven't put this little wire cover for the rear gantry on there yet. So, Project Alex, this is Frank from the Calico crew and the Voron team, and Armchair Engineering, and what's you got on
Cocoa
your
Press.
Cocoa Press, and
I'm sure there's more I'm forgetting right now.
okay, so we have made those changes. Did I save and restart? No. Save and restart. Let's get rid of this. And happy? So now we're going to go back to, yeah, this is good with you. Home all. Hey Liz, welcome. Okay, so we expected that. We didn't change anything. But if I go in here and press the button once, we're gonna go to the next sensitivity setting. Can I just, no, this isn't gonna let me do just. There we go. Yep, and a little light tap took care of it. Huh?
That was perfect.
Yeah, so now we're gonna do that one more time and let it go all the way to the bed. So I'm a big proponent of always early triggering Z manually in some way, whether it's put a piece of metal under there for inductive probe or push up on a tap, whatever. You don't wanna trust your first home into the bed.
I have way too many sheets with holes in the PEI.
Mm-hmm. So at this point, I think we can do a QGL. Right?
Looks good.
Okay, so here is another thing that should be out on their docks. So that moved and immediately triggered. We need a dwell time on there to wait half a microsecond, a fraction of a second before it actually does the home for things to settle. And I thought there was code here. No,
I think that'll be in the, we go back into the probe section and add it back to the activate G code there.
Yeah, there it is. Yep. So that G4P200 is that that wait 200 microseconds. Hey, Alan, welcome. we go back in here, and now we want to just grab this part of the activate G code. Save and restart. Milliseconds. Thank you. I should have known that. Let's close that. And now we'll go ahead and do a home all again. Well, I didn't like that.
I think that X triggered early.
Huh?
I think the X homing triggered early there.
It did. It did. So, why did it trigger early? Let's go back and do a similar change to where we did. We'll redo the setup. Motor's off. Let's go back and do a similar current and then value dance to make it a little, because this is a little lighter tap than Y is for X. So let's just go with a little stronger first tap, and we should get still a nice soft second tap, right?
Yeah.
So if we come into go into config, come up to X. I'm going to change our home current up a little bit, right? Or do we want to go down? We want it to...
A little up will make it less sensitive.
And then go back to 1 as our first try. Save and restart. Oops, I didn't show any of that, but I changed the current to 0.7 and the SGT value back to 1. So then we can come in here and just home X. Okay, so it's too short. Let's go in here and go up and find our X. Let's change that to 2. Oops. There we go. Keep that to 2, and then we'll try homing X again. Now, it did an early homing trigger on second home. Early homing trigger on second home. Any thought on that? Try going the next value up and see what happens.
We're at 0.7 amp and 2.
Uh-huh.
I mean, try 3.
Yeah, that's what I was thinking. Let's move this back. And home X. Okay. So it's less sensitive and it's still triggered early on 3.
Morton was saying a higher homing speed with the 5160s gives better results.
Okay.
So let's try 80 there. That was the lower bound of his suggestion.
Okay.
Drop SGT back to 1.
Yep. 80 for X. And SGT down here is 1. Should we go a little less on the current? Go back to our 0.6?
Let's try that, yeah.
Just so why it was working. So I'm not going to mess with that. So you can restart. Okay, so then all I'm going to do is go in here and do I wish that the error messages at the top of fluid would go away on on a restart, because you look over and like, oh, did it error? No, that was an old one.
Yeah, I'll let Pedro know that that could be nicer.
So it home early, so let's change that up to 2. Let's see what happens. So I just changed it to 2. It's triggering early. Let me...
And that one moved a little diagonally.
It did. I did notice that too. Let's see that again. Yeah, there was a small diagonal move.
And the X and Y currents are the same?
Homing current is different between them.
Because it's core XY, they should always be the same. Since it's not really X and Y steppers, it's A and B.
Mm-hmm. Correct. So I'll need to change this. If we had to run 0.7 on Y, then we need to run 0.7 on X. Because we didn't do that before. Is that, you think, the source of our issue here?
That could definitely be confusing things, yeah.
Mm-hmm. So I
One
just
stepper's
changed them.
pushing harder, pulling against the other, triggering the other's current sense.
So I set them both to 0.7. Let's try the X. Still doing that. Still doing the weird.
All right. Morton is saying he does 0.7 amps, 80 millimeters a second, and SGT is either 1 or 2, depending on the printer.
Okay, let's double check here. Let's just go through and make sure I haven't screwed something up. So we have our stepper X, homing speed is 80. And then these one. Okay. And then the TMC setting, our run current is 1. Driver SGT is 1, and our home current is 0.7 for X. So for Y, we were getting homing speed. That doesn't have to match. We're going to leave that. But our current is 1 and 0.7. All of that is the same. So let's close this air out.
Just to point out another fun Calico feature. As you go back and forth editing the same value in 2 places, we've added support for references to other locations in your configuration.
Okay.
So you can say my 5160 stepper Y run current is a reference to the 5160 stepper X run current.
Ooh.
And then you update one and both change.
How do you do that, and where's that documented?
The configuration reference.
Configuration reference.
One more section up.
Configuration reference. Yep.
And then it is the configuration references heading on the right under danger options.
So we're looking for these for different stuff.
Yep.
In your configuration, you can reference other values. References take the form of... Oh, okay. So
and if you want, you can move these shared values into a dedicated constants section, as shown at the top of that little block.
Oh.
I like to do that, so I just have one block at the top where it's my run current AB. And then in each of the 5160 sections, I just say that's the value to use.
I am not used equals true. We'll show constant I am not used is unused. What is that? What is that?
It'll give you an error if you have a value in your constants that you're not using.
I see. Now, do I need to enable that danger enable?
Nope. This is just available by default.
So if I copy this and I want this I am not used part.
No, that's
I don't
just
need
an
it.
example of what an invalid option would be there. And it won't be like a full clipper configuration error shutdown. It'll just be the yellow warning at the top of fluid saying, this value is not used. You should probably fix that.
If we go all the way up here, we wanted to change things. So I would imagine maybe down here right under printer or something would be a good spot.
Perfect. And then you have the run current. You can add a second home current AB.
Okay, and then I come down to the TMC stepper X and we say run current is, if I come here, we go run current is constant.
That. Yep.
Constants run current AB. And then home current is constants home current. Okay, that's really cool.
I have a list of 15 or so values right at the top there. That way I can go through and tweak my entire configuration and it all just cascades down. It's also nice for multiple Z steppers. I'll define my first stepper Z section, and then in the stepper Z1, Z2, instead of even referencing constants, it just goes stepper Z dot something so that it's using the first stepper's values.
Got it. That's really handy. Home current. Okay, so that sets all of that. Save and restart. Can't you have end stops and have it calibrate itself? As far as what? Okay, let's see where we're at. So if we home X, it's doing a diagonal move on home. Why? And it won't home Y before, because of the way this is set up. Homing overrides. That's really, what did we change in the rest of this that would cause it to suddenly not?
I don't like that.
Huh?
Is there a second section at the bottom of the configuration that's accidentally overriding one of those values?
But we had it working, editing these values.
We did.
Let's let's change this. I want it to just go ahead and grind. I'm gonna change this to like 5. I want to see if it will move properly if the value is less sensitive enough.
We did change the homing speed.
But not before all this happened. That was all kind of trying to reset to something that works better.
True.
So if we go X here, that's with 5. Oh. Something's very wrong if it did that, because it moved forward first.
That is.
Gantry's moving fine. So why are we suddenly getting, so that would indicate some sort of, maybe a, here, let's do this. Let's just go back to basics. Let's stepper buzz.
Yeah, let's do a stepper buzz check again.
Yep. Stepper.
Thunder keys, all thinking the same.
Yep. So let's stepper buzz.
No, Kali. 0.7 or just 0.7 get parsed the same.
That's weird. That, could you see that? That was the stepper buzz on X. Let's see what happens on Y. That's normal. That's a normal stepper buzz Y. Here, I'll show you stepper buzz X again. This is done. Something's going on with the B stepper back here. You see that? It's just vibrating, like it's not actually doing a 1 millimeter.
Is that stepper really hot right now?
No, neither of them are. So someone said that started with the dwell, and it did, but I think it's not engaging.
On that.
Huh?
Let's triple check the crimson wiring on it. That's my gut feeling right now.
Absolutely, that would be. Let me just double check something here. There's nothing that should be. Do we need to deactivate G-code, even if there's nothing in there?
No.
Huh?
That would only really be if we need to restore those currents.
Just because this is the, I mean, I think it's probably worth the 2 seconds to see what that does. I'm just gonna stepper buzz X. That did it. It's stepper buzzing fine now.
Ow.
I don't know. I mean, I agree with people saying that was the lowest hanging fruit to try, and it took 2 seconds to try.
You want to send me your clippy.log real quick? I want to take a look at something.
Where do I get that quickly? Here. Sorry, here in system. Clippy log. Oh, there we are. Save this. Tia in Discord.
That works.
Okay, there you go. The whole thing's there. But what in the world is causing that? So can we simply, let's comment out this and then comment out that.
Just to see, I'm comparing the last 2 restarts configuration.
Yeah, having the deactivate G-code there worked. Deleting the run current stuff and just leaving deactivate G-code with no value in it. It's got to be a... Okay, so while you're looking through that, I'm going to go ahead and retest homing and get the homing going again. Okay.
Yeah, there's no other differences. That's just bizarre.
But it's got to be causing the next, whatever the next thing to process isn't processing right. So it's screwing up some section. Clippy log shows the end result configuration, right?
Yeah.
And what's the next thing that shows up there in the configuration? want to see where I'm at on, oh, I think I need to go, I'm looking in the config here where I'm at. We're at 1.
Right after the probe, it has the bed mesh section.
Hmm. Here, and we're going to try SGT 2. X. It did not do the second move. Why didn't it do the second move? Did I just
If
not
it
notice
moves
it?
far enough if it moves far enough the first time, it doesn't need to.
But I thought it does the homing retract, and then I thought we had it set.
If it moves below a minimum first homing distance before it bumps, it'll retract and then go again.
Oh, so we
And
never
that's
actually set
that's a
up the
safety
second homing move.
No.
Okay.
And that's partially so, like, if you're all the way on the right edge and it only moves half a millimeter and bumps, it's going to say that was either my threshold is too low or too sensitive. So let's try retracting and doing it again and seeing if we get a similar end result position.
Okay.
And if so, we know that was a valid homing. If we retract 5 and then home and get half a millimeter of movement again, we know there was an error.
X. So Y triggered too early. I changed the sensitivity up. So try. There we go. Okay. So let's go in, and 2 at both of those seems to work. So let's change. So I could set a constant. Well, I don't really want a constant for these. These are tuned values.
And they might not be the same for each stepper,
Right.
theoretically.
Yep. So that's Y and X. Both of them ended up at 2. Okay. Let's go back to where we were. See if that dwell time fixes the home all. Home all.
Blank. These are TMC 5160s. They use a driver SGT value instead of the SGT HRS.
Okay, now QGL. Whoa. Ooh. That was weird.
That looked like the X run current was too low at that point. Or like jittered forward. Would that be A or B?
I'm going to cancel it because it's not going to QGL when it's not probing the same spots. So just do a quick restart. So you said what? It looked like the home current? Not the home current, the run current.
The run current.
Let's look at what our QGL settings are. Where is... Isn't there a reference? What is the... Oh, that's not what I wanted. That bookmarks. Quad gantry level. It's trying to go to 100 millimeters per second. It tried to do that. Only on that. Only when it got past the
Are we having more issues with that B stepper at lower Z positions?
It's the one stepper that isn't, I mean, the wires just go straight over to the thing. Yeah, let's check the wiring over there. Let's check it. Let's turn this off. Shut down, accept. Let's just open this up. Open up the back panel and check. Go. Doesn't take long. Some of these little twist clips can be quite tight though. If you're gonna use these, I recommend having extras because they don't take too many tries before they'll twist. That one there is starting to twist. Okay, and then I have, yeah, that's still, so it should come out. Get a good look at my nightmare bundle of wires back here. What's up?
Hey, Garrett.
Hey, Garrett. Okay. Let's see here. Look at that. This is a pretty common thing, even for me. Nope. See that?
Yep. That red wire slipping out.
Yeah. Yeah, those really need to be pushed all the way in to click into the housing there. So, and that is the B stepper. Vitali, thanks for the memberships.
Hey.
So speaking of, something I didn't mention at the beginning of stream here while I fix this. 2 days ago is the first stream I did in the Trident build, the first Trident build, 4 years ago. So I've been streaming for 4 years now. It doesn't seem like 4 years. Let me get in here. That first stream was done in Discord. Be quiet so I can hear it click. Yeah, that right up in there. Let me double check the other one. Those are all in. So I was able to do that. That should do it. Almost never is good to know it can happen to us all. That one issue there, especially with microfits, it just feels like they click in when you're building it, but it didn't click in. Yeah. So,
or there's two locking tabs. If you get just the left side, the right, a little bit of vibration, and the crimp moves to the right, and that tab falls out of place, and then the whole thing's loose again.
Yep. Always do a tug test. Mm-hmm. Does it seem like COVID started 6 years ago, the last 4 to 5 years? Yeah. It has been gone by like a blur. something else I did between streams on this is I wasn't super happy with the way that my filament path was going. So I remodeled the holder here, put an angle on it so that and then I remodeled the mount here to where it doesn't also cover holding the panel. I need panel clips. It doesn't have tabs for the panel. So this is 2 screws going in here, so it's nice and solid on the extrusion. And then this guy comes on here, and then that puts it kind of center of the spool and then angled down so it wasn't such a sharp bend to get into the path here. Okay, let's power this back on, see if we can get on to the next phase.
I'm guessing the firmware didn't throw an error for that phase being disconnected because it was just a poor connection, so we weren't seeing a full. That would be a would that show up as a short to ground error on the drive? One or the other.
Okay. I think everything should be saved. So let's just see if a home all works. Okay, and then a QGL. There we go. We should see a pretty dramatic change here. There we go. It was quite out.
So another new addition we have, you have your quad gantry level horizontal move Z, so it's lifting that value each time it goes to move across. If you set adaptive horizontal move Z after that, the first one will do the full lift every time, and then it'll look and see, okay, I probably have at most this much skew left. Let's reduce the lift I'm going to do for the next cycle of taps each time. So each cycle of level probing, it's going to lift less and less and go faster.
So where is that under the
quad gantry level section?
But is it listed under Calico editions?
If it hasn't made it in there, I will fix that later today.
Probes and probing. Safe Z home.
Yep, one up above that. Right above the safe Z home.
Increasing threshold allows you to customize the allowed variation when probing multiple times. Is that
Next
it?
one. The Z tilt.
Oh, adaptive. Okay. Adaptively decrease. There we go. So what was that? Adaptive horizontal move?
Yep.
Is that it?
And it's the same option there regardless of Z tilt or quad gantry levels.
Set it true to automatically adjust. Move after the first adjustment. When enable the initial horizontal move is to the config value. We'll set to the what? Seal of air?
Seal is the ceiling. It's the largest value.
Okay. Or minimum horizontal
Basically
move
rounding up.
Do we have minimum horizontal move Z defined?
It defaults to 1.
Oh, okay. Adaptive horizontal move. Oh, minimum horizontal move Z. That's that one, right? Defaults to 1. Got it. Let's put this in. Let's put this in and try it. I mean, the whole point of this is to try Calico features, right?
Yeah.
So if we're spending time getting things configured with the quality of life stuff that we have with Calico, then it's good time spent. It's right here in the QGL section, right? Are they going at it? Better view there. Save and restart. Okay. Back and do a HOMA. Had that finished? QGL? Yeah, it ended it with 0.006. Okay, HOMA again. QGL. Yep, there's a much shorter move.
And it doesn't matter quite so much on the Micron, just so much smaller, but like my 2.4 or something really big with slower Z motors, it makes a bit bigger difference.
Awesome. Okay, what do we want to do next? What do we have? Oh, something that I do need to set up that I don't think is none of my fans actually work. Yeah, I don't think I have any. Do I have this one working? You know, the best way to check if a fan is working is to shove a wire into it. It does.
I usually use the zip tie that is just near the printer and I accidentally bump into it anyway.
This is a thin gauge wire. I wasn't going to break anything. You put an old build sheet in bottom when doing this sort of thing just in case things plummet down. Sometimes, if it's a brand new setup, but I'm try to, if everything, it's a known firmware, the probe is working, I usually just send it. But if you're really worried about your build plate, yes, put an old sheet on there. Shoot. Oh yeah, I wanted to get I have one fan working. I have them set up on different ports on the controller because I wanted to set one of them up to always be on and the other one up as a controller fan. So the problem is I don't know which port I plugged it into and my phone's in the other room with the picture that I took of the controller. So what, let's table that then. And maybe I'll go and grab my phone when we're in the middle, when we're waiting on some other process. So the next things we need to do are, I need to do like extrusion, calibration, and then input shaper and stuff, right? Start going through some of the specialized tests. So before we do that,
Sorry, you'd already set up the model predictive control for the heater, but you've added the temperature sensor since then, so we could set that for the ambient temperature measurements.
So where is that in the config reference? Is it under extruder?
I believe it'll be under the heaters.
under the heaters. What it's called, ambient?
It is extruder. You're right. The option is ambient temp sensor.
What's that? This page. Oh, where's extruder? Extruder. Okay, it is down here. Ambient temp sensor. And is there any more detail on this? Looks, oh shoot, I haven't been showing any of this.
If you go to the full model predictive control page on the left, the left side index.
That is under...
It's under the configuration, right there.
The basic configuration.
The last of the optional configuration parameters.
Ambient, okay. So it is recommended not to specify this parameter and let MPC will estimate. This is used for initial state temperature and calibration, not for actual control. Any temperature sensor could be used, but the sensor should be in proximity to the hot end or measuring the ambient air surrounding the hot end. So it would really only matter for recalibration in the future. What this will do is when it's measuring the ambient heat loss from your heat block, it can use this to get a more accurate measurement of that heat loss. And right now it just assumes I think a 25 degrees Celsius room temperature. And so when it's measuring the loss as it changes the fan speeds, this will use that ambient measurement instead of just the estimate. And you'll need the full temperature under sensor. Huh?
You'll need the full temperature sensor name, not just the chamber. Yeah.
Temperature sensor, and then what's the syntax? Is it listed here, temperature
it'll be
sensor
space,
and then
just the
sensor name.
name.
Okay. Let's see. And then I think is it just chamber temperature, or is it, where is that thing? Here, should be down.
I have your configuration over here. Give me a second.
Where is that thing set? Chamber temp. Here.
I think it's just chamber.
Chamber temp. Yep. Chamber. Sensor pin is chamber temp. Heater generic is just chamber. According to this.
Temperature sensor.
That's how this is set up. It doesn't seem to have a
It's on a fan?
It's set up as on the bed fan as a heater. I've got it on my screen here. Can I use that?
Yes.
So
I don't know.
chamber. So it should be chamber, right?
I think you would use the heater generic chamber, but I'm not positive, honestly. I've never used it with a bed fan.
This is the default config that Kyle set up, or whoever set up for it. Should be able to get an error if it's not going to work.
Restart and it'll error, and if so, we can just remove it and not worry about it right now.
Sensor type and section temperature sensor chamber must be specified. Do I have the syntax wrong on the? Oops, I want here.
No, I think it's just because it's the heater generic chamber instead of a just a sensor. Let's just skip this part.
How would
for
you
now.
use the extruder? How would you use the extruder as the extruder's thermistor? You
The
couldn't?
thermistor in the extruder,
Yeah.
if you let
Or
it
the hot
sit and
end.
idle long enough, you can take that initial block temperature, assuming it hasn't already been pre-warm, and assume that's your ambient.
Set it up as a standalone sensor, then use the temperature combined as sensors in the bed fans and extruder. So how would I do that? So
that would work, but I don't know if it's going to be worth it, since it's mostly for calibration instead of active use.
We won't dwell on it then. Let's save and restart. Okay, in order to enable some of the other bleeding edge stuff, we need to reflash the firmware. So let's do that real quick because it'll only take a moment. Then we can talk about some of the bleeding edge stuff as well.
If you want, I can start explaining this one while you're doing the reflash.
Yeah, please.
So Clipper works the inverse kinematics for controlling the motors by kind of brute forcing to figure out what stepper movements are going to correctly move the tool head where it needs to be microsecond by microsecond. And it's splitting it down into step by step, and then compresses those sequence of steps over time into a single linear set of movements. And it's fairly accurate. There's a error margin that's allowed, so it might be plus or minus 15 nanoseconds on the time that each step is going to be happening, which that's great. That's more than good enough for most use. What this change, the high precision stepping and the new step compression protocol is going to do is, instead of just doing this many steps over this period of time with this adjustment, it takes it and uses a full polynomial. So instead of saying this is just a curve on a graph, this is multiple curves that explain the sequence of steps. So we can get far higher precision for the timing of each of those steps, and theoretically get much better or smoother accelerations. And it is much more computationally expensive on your microcontrollers. You probably don't want to try this if you're still using a SKR 1.3 or a 8-bit microcontroller like an Arduino, a RAMPS. But with a modern STM32s, this isn't going to slow them down.
Going through the real quick reflash of the MCUs to make sure they have that high precision stepping feature turned on. And that was basically done within the time of your explanation there. Works pretty well.
The timing pretty good there.
So, firmware restart.
And so the microcontroller supports it, but nothing will actually be using it until we go into your printer configuration and tell it for each stepper you want to be using this high precision mode, the option for it.
Okay, so where do we find that? So this is under
that is under
edge,
the
right?
bleeding edge, the configuration reference for bleeding edge features.
There we go. So let's go here real quick. We did high precision stepping, new step compress, which you just explained, right?
Yep. And if you go to the discourse link at the top of that section, There are some really detailed graphs that show some of the differences here. They're not that easy to just look at and understand what's going on. But when you drill in and you read the 20 pages of discussion there's a lot of information.
So if we go to configuration reference for bleeding edge features, and we want high precision stepping. So this feature is enabled. So that's what I just did, is this part where I just reflashed. And we covered flashing these last week. All I did is change an option and redo it. Following configuration line should be added to each stepper. So high precision stepper compress equals true.
Yes. And you only really want that on your X and Y.
Okay. There's no advantage to extruder or Z or anything.
No.
Would there be an advantage on Z when you're trying to move it really fast like you do on like a stealth changer?
If you were doing a lot of, like, let's say you got non-planar printing working and you were doing lots of Z movements mid-print, you might see a difference there. Just for the quick movements for stealth changer, it's not going to do anything.
Okay. So we go up here in the main, just throw it up in here. Stepper X and then stepper Y, right? Okay, and that's the only change, it looks like?
Yep.
Save and restart.
Save and restart. And it's running.
And that's it. Okay. So what is next that we want to set up? Is there anything we need to set up before we go into more? Because we're going to do some input shaper testing. I never installed Shake and Tune. Should probably start that real quick. Let's go Shake and Tune. And is there a installation?
Just the one command goal.
There we go. Copy that. Here. Just home and run. Hey, Jason. Hi, Rachel.
Rachel was having me explain some of this to her last night for practice, trying to break down, like, no, that's a high-level math term. Most people aren't going to understand a cubic versus a quadratic versus a polynomial.
Oh, it's homed. I'm going to go ahead and rehome. No, never mind. It's running. It's going to restart anyway, I'm sure. I have like a week and a half to get ready for Orange County Maker Faire. How far is that? How far is that for you? If you were to go there, what's the drive time?
Drive? 13 hours, I think.
Oh boy.
Let me check. That's Santa Ana?
Yeah.
Oh no, that one's only 7 hours.
7 hours? Only?
It'd be 14 or so, up to you.
Are you flying into Portland?
I don't want to drive that. If I'm bringing the kids, like, that's a torture for small children.
Oh yeah, yeah. Okay, so that is installed. I think we are. Let's reconnect. I think it's good here. Oh, I had restored my history database on here, and I've got a grand total of 24 minutes and 45 seconds of print time on this printer. The test cube.
If you're not using it, you can just leave it with me.
The plan has been to use it. I got caught up in like fine-tuning input shaper and stuff when I first built it, and trying to get early versions of Boop working, and then I rolled into trying very early revisions of R1 onto it. So it's never, it's been in a state of change up until now. So okay, let's home all. Okay.
I just got told no more printers.
No more printers? My wife used to say that. She used to say, you got to get rid of one to get a new one. And then she gave up.
I think I'm at 11. And 3 work?
Yeah.
Oh, it's bad.
I think I'm at 35. And I don't know how many don't work. Let's do a final home.
The problem is, I don't build a printer that I think is going to be boring and just work all the time. I build projects, and then when they start working, I get bored, so I make them into a project somehow again. Like, my V2 is currently not working because I put servos on it and then blew up the servos.
Oh.
Yeah. That was an expensive mistake.
Okay, I am going to run a probe calibrate real quick. And I'm going to use my patented Chris Riley nozzle distance measuring device. What do we got here? Down. I'm just using this interface here. Good right there. Accept. And save and restart. New offset of minus 0.076.
Feels about right. Servo smoke is still white. It just feels more expensive as it comes out.
Got a little gold tint.
Let's see. I think I've got it right down here. Yep. Just one of the phases is completely fused. Don't know if we can.
Ouch.
Yeah.
Now, recommendation that came up in chat last stream is to just use PID for the bed. You don't get any real benefit off the bed.
Not as much. It's a large thermal mass, and model predictive control is about modeling the ambient losses for a given thermal mass. So with the lower losses, you don't get much benefit from it, and it is more computationally expensive to be running.
Okay.
Velocity PID, depending on what thermistor is on your bed, might be worth looking at. Normal PID is adjusting based on the target temperature, or the difference between your current and your target temperature. Velocity PID looks at the current rate of change to feed into its control loop. It's
So
more sensitive to noisy sensors, though.
This just has a, I think it's just a beta 3950 in the bed. We can check that.
It'll work. You're just not going to see a huge benefit for it. Because of that huge thermal mass, it gets to temperature and mostly just stays there.
Okay. Let's go back. Click home, do a QGL. And I think we already confirmed stepper direction. So we're going to do a Extruder Calibrate, rotation distance calibration. Okay, let's move this up so I can get to stuff. That's probably good. That. Okay, that looks about right. Just want to make sure it didn't move further than I thought it would. Go ahead and pull that nozzle out. Just want to make sure what we have in here, and then we should be able to set a minimum extrude temperature really low so we can just cold extrude, right? Right through here.
Yep. I use force move for that a lot.
Force move?
Yeah, because then you don't have to worry about your minimum extrude temperature.
Come on, there we go.
And Calico does enable force move by default, so you don't even have to go add the section.
Oh, okay. So let's do that. And then let's grab some. For today's testing, we're going to use this Greengate ABS that I got from Murph. I've done a print on it. It turned out really good. Nothing special to talk about. I don't know how it behaves in terms of printer parts and durability and stuff. They do say they're using Techmer 1512 resin. That doesn't mean anything to me, but I don't know if that means anything to anybody. Cut off. Let me just cut off a section of this so I'm not dealing with the spool. Okay, clean spot. Put this in here. Why isn't that? Oh, that's weird. It's not actually even grabbing when I manually move the thing. What is going on? What is it hitting? It should be able to. A
little piece of filament left in there?
No, this hasn't had filament in it. It's not actually hitting the gears there. What is, let's see if I can see it here.
Where do I mute that notification? There we go.
Ah, interesting. Okay, so what I think is going on, which I didn't check before, is I think my filament path through the printed part here is a little tight. How do I fix that? without causing all kinds of trouble.
You could try just pushing the filament up from the bottom. See
Well,
if it goes through easier that way.
but it's tight through here, which is going to impact. It needs to be a clear path. I think I'm going to just drill it out in place. Let's see how that works. Yeah. But I want to be able to get a better, better access to it. Ah. So let's take the top panel off. These little twist locks can be painful. Ow. Focus. Oh yeah.
Those look so much easier than the screwed on panels though.
I am surprisingly pleased with how they work out. I was skeptical.
Have you tried Zruncho's Zero panels?
No, I haven't.
Those are nice. They're just snap-on. It's a pain in the butt to get the prints calibrated just right for how thick your foam and how thick your panels are.
Mm-hmm.
But when they work, they just work.
Where's my calipers? Where are my calipers? Where are they not? Right. Oh, they're over here. Let's see what this is. 2mm reamer. Where is my pin vise? Because this. Where is the pin vise? Because it was in the toolbox here. Know that I've seen it. Where is the pin vise? That's weird. I don't know where my pin vise is. Well, maybe I'll try to do this by hand. Maybe it won't take much. Yeah, that's not cutting very well. Let's switch over. Curious where my little pin vise went though. Switch over to an actual drill bit. Something small, smaller than 2mm.
Bought a set of 1.8 drill bits, just like a dozen of them.
This is 1.87. That's what it measured to. I just grabbed one that looked the right size.
Right there, close enough is good.
Just should only be making plastic debris, so okay, let's see how that does. Oh yeah, much better. Okay, that's normal. Hopefully it's not. It's probably going to be tight on the other side of it too, but I can't do much about that at the moment. We'll see how it does. Okay, so what's the force move command? You have that offhand?
force under move, and then stepper equals stepper X or extruder. Velocity equals
force underscore move.
Yep.
Stepper equals extruder velocity equals,
and then I think this is in.
Yeah. Let's go 600.
Let me make sure it's.
No, they need to be less than that. It should be millimeters per minute, right?
I'm trying to. The velocity is millimeters per second here. Does not match normal feed rates.
Huh?
It's millimeters per second, not per minute on this one.
Really? Okay. So velocity equals 2?
Yeah.
Actually, we don't have anything obstructing it, so we can do like 5 and be fine.
And then
I don't have a hot end in here.
Equals, and that's in millimeters.
Let's just go 25. I just want to make sure it'll get past the next part of the... Okay, so let's see. Yeah. It's jamming up at the next stage, which means I have to take the extruder off in order to fix that. Okay, well, that's what we do.
At least with it, had it's only a couple screws there.
Yeah, I don't think this will take too long. Shut down, accept. Let's pull this out and screwdrivers. So I think I should be able to get that screw going into the motor back there. And let's pull this off. These guys out. Oh. Those two out. Then can I get don't want to do it that way because I'm going to lose my mesh and I don't really want to recalibrate the mesh on the, so let's leave that and take off this side. Yeah, this is all just fresh build things. Figure stuff out as you go along. What if I do the bottom grooves here? Now, come off of here? Who's holding that at this point? I think it's that center screw. What size did I use for that?
Yep, the one in the back, 2 on the sides.
One in the rear,
I think
the middle.
that's it.
From the rear, the middle one. Just got to figure out where or what size screw I use for that. Doing it blind. Where are you? There it is. Oh. I've got a lot of sensitive stuff here. Gotta get that drill bit again. Can I get in here just enough? Aha. Let's give myself a little more room to snibs it tired. There we go. Wish I knew where my pin vise was, because I can't get enough grip on this. Wish me luck.
Mm-hmm.
Oh, very, very slow and steady.
Before you put it back on, you should test the filament.
Yeah. I was just gonna set it down so I'm not straining on wires. I think that's a little, I want to go a little, I think I want to go to the next size up actually on both sides, just because I feel like there's a little bit of friction on the top one. So this is going to be somewhere around 0.9. So oh. Now we'll try. Yeah, much better. There we go. That did it. Sure. Not pinching any wires anywhere. Go. Let's go. Little. Okay, no pinch. No pinched wires. These guys on the back. Okay. Oop. Then cover. Nope, nope, nope. Zip tie. Gotta get that.
I'm getting random messages on Discord telling me not to smile.
Don't smile. Who's telling you not to smile?
That one was Pepper King.
Go. That was probably the most common thing someone said to me as a kid, because I guess I never smiled. Okay. Blue guy. You're now dubbed Blue Guy. You see that in chat?
Blue guy.
Uh-huh. Blue Guy, are you the
Is
maker
that
of the
me or
Micron?
Bob Kearns?
No, that's John.
No.
I think they're talking about
Hartk
your
is
shirt.
the designer of the Micron, and I haven't seen him in chat today.
Yeah, I had Hartk on when we built this the first time. I wanted, from the beginning, planning this build, I wanted to get someone from the Calico team on. So either you or Roger.
Roger's on vacation, so you had to make do with me.
I would be happy with either of you guys. Okay, let's power back on and get back to this. Hey, Keith. Hey, Christoph. Oh. Blue Guy, can you introduce yourself?
Am I Blue Guy? Who are we
You're
talking
Blue Guy
about?
now. You're Blue Guy now.
Oh.
Your blue shirt.
Oh, it's half blue.
Well, what we see
It's a
was
sunset.
blue. We only saw the blue part.
All right, I'll introduce myself again. Hi, I'm Frank. I'm one of the developers of the Calico firmware, member of the Voron team, armchair engineering, Cocoa Press. I do a little bit of everything printer related at this point.
You are now dubbed Blue Guy from now until the end of time.
Are we going to start the Blue Guy group?
There we go. Straight on through. Okay. Back in business. Do you have a full-size refrigerator in your workshop, or is that your kitchen setup? Oh.
So my kitchen is right through the arch there, and that's my second fridge for extra ingredient storage and extra space for like whole cakes or baked goods and whatnot.
Okay. Let's get in here, make our 100mm watch, or mark. There. So now we will do the same force move, but 50mm.
This fridge has the slide out drink drawer, and when you pull it out, there's a printed label on it that says beer and more beer. So yes. And the fridge doesn't run Clipper. My pellet smoker outside does.
Nice. That is exact. There's no adjustment needed. So looking at my marker, I mentally noted where on my little mark it lined up. It's lining up exactly on the same part, but at 50. So if that didn't, then you would take the difference, do the math, adjust the rotation distance. But with this, there's no need. Let's do this again, but minus 75. Get it out. So where did the name Calico come from?
Was the result of weeks of brainstorming on a name. A clipper's a small sailboat. A Calico is another type of small sailboat,
Oh,
and we liked the thought of having a cute little pirate cat as the mascot.
nice. And it just so happens to match the colors of the printer build, colors of my mascots.
I need more Calico stickers. I'll have to order some.
Okay, so that means that the basic compute or printer stuff is configured and ready to go. We did the PID tune. We didn't PID tune the bed. I don't know if I want to go through the time for that right now. We can get into. So is the boat Calico spelled with a K?
No.
Oh, okay. Just spelled with
Keeping
a
the
C.
K was an homage to Clipper.
Got it. Okay, that means we are now at, we can do some of these test prints, right? Input shaper. Let's do input shaper. Is that where we're at? Am I missing anything? Put the panels back
I think
on.
we're ready.
Yeah. Let's see what we get. These back on.
Andrew, I do see chat. Black October is your first trident, like the Red October. I like that. All of mine are currently named after moons of Jupiter. I figured if I actually run out of moons, I'm in trouble.
How many moons does Jupiter have?
A lot, and not all of them are named. 97 at the moment.
Oh, okay. I've got a long ways to go. Mine are very creative. This is Micron. That's VT gray. That's V0 red. Hey, Micro Viking. Hey, Troy.
Oh, that was Voron.
Voron.
And then that was also Voron, and that became a problem with DNS, so that became V1112, and this was Voron 0 because I didn't serialize it, and I still haven't. I need to fix that. Salad Fork, and then got renamed to Doom Fork when it got rebuilt.
My first Voron was Voron 449 was the name. Now it's V2 Black.
Phoenix is Fire Chicken.
Ah, okay. I'm a fan of a meme that went around. It's a Molotov cockatiel. Did you see that?
No.
Oh, my phone's not on me. Oh, actually, I can get it. Here, I sent it to. Oh, maybe I sent it in text. It might have been in text. Let's see. Did I send it? Yeah, I sent it in text. It's going to be too hard to find. Never mind. Okay.
Cocoa Press is still named.
Hmm?
Oh, Cocoa Press doesn't get a fancy name because it gets factory reset every other day.
Oh, yeah. Okay. Are we good here? Let's go ahead and home all. Then we should have. Oh no, we have to go back. Let's go back to Shake and Tune, and we need to grab our which means we're gonna have to rehome. But let's copy this. copy this and add our shake and tune stuff. So let's add a file, shake and tune, G, paste all of this in. I don't think you have to actually do anything with this, right? You just need a shake tune section.
Yep.
Save
And you need to
that.
have a shaper calibrate section, I believe, as well.
Oh, okay. Let's get up here and throw this in one of our includes. Include.
You might not need to anymore.
Shake and tune.
No, you need the resonance tester section.
Do I have that already? Yep, I have resonance tester already. So save and restart. Okay. Does anybody have any creative, maybe not normal printer schemes? So this would be, you have more than one printer and you've picked something that most people wouldn't think. What's that? I mean, moons of Jupiter is pretty unique. I don't think many people are doing that. But spaceship names is probably pretty common. Droid names, okay.
At one point, I was using planets from Star Wars for server host names.
Oh, there's a whole thread in Discord with printer names. I know, I saw that. Just the color. And on the water. Okay, that, and then we do want to do a QGL. Just want to make sure we're doing this in a tram state. My flat trident is called Flapjack because it's a pancake printer, okay? My most unique printer name, the most unique printer name I have is Charlie Wire. That's the one that doesn't follow the scheme of the rest of them.
Next stream, you should just put up a poll and have people suggest and vote on names.
I would never remember it, is the problem.
You know, Stephen, I think P-Noob would have to have finished the stacked printer to have gotten to the point of naming it.
Bond Girls, that one's unique. Printy McPrint faces. That's exactly how you get that. Is you put a poll
It would
up.
be memorable though.
Okay. Home one more time, and then we're gonna run. So we'll do a compare belts and see what that looks like on my setup. Or do we just want to do a shaper calibration?
If you're confident in your belts, skip it, but I like that one a lot.
Yeah, me too. Because we do that. It's vibrating. Nordic theme for naming printers, okay. Nebuchadnezzar. It's quite hard.
I would never remember how to.
Yeah.
I wouldn't remember how to spell that to
Yep.
type it in.
Is that actually how it's spelled?
I think so.
I would not.
Cat rig, nice. Have you seen the cat front shell for the tool head? Trying to remember which tool head has that schlocky.
Significant. Significant vibration somewhere. I think it came from the door handle here.
I just had a fire chicken thrown at me.
Where that's coming from.
Deck panel?
Yeah. Maybe? I can't really touch that from here. I'm just seeing touching anything changes it. You can hear it? Yeah. There's lots of, I mean, throughout the range here, there's been a few areas that really vibrate. We'll see what that looks like in the graphs. Okay, that finished. Oh no, that was just one. That was just one part of it.
That was just the A or B. I can never remember which is which, but
It was A.
One
Now
belt
it's
and the
measuring
other.
belt B. Using pulse only test. Do you know what that is?
So recently Clipper added sweeping resonance testing, where instead of doing the short little back and forth
Right,
vibrations,
right.
it's more of the long sweeping back and forth. And that's really good for certain kind of resonance measurement, not as great for others. So I'm pretty sure that's what ShakeTune is saying there.
Got it.
Frick's around today.
Huh?
Is Frick's around today? I want to ask him a question.
A big part of that is the rear belts are vibrating against the back panel. Was part of the noise.
Makes sense.
That's pretty good. It's exploring. I do not have a decibel meter. Aside from what's on my phone's in the other room. Okay, that done. Belts, this may take some time.
You're on a Pi 5. It shouldn't take that long.
No. Cleaned up. Okay. So let's go over to here. Shake and tune results. Belts. There is our belt profile. Estimated similarity 98.5%, but these outliers is not what you want, right?
Do we have Reth in the chat still?
Breath. calling all wraths. Apple Watch has a built-in decibel meter? Oh, does it?
Oh.
Which app
I think
is
it's
that?
98% similarity. Unless you want to really tweak, you're in a
Ear
decent
icon.
place.
Yeah, I'm not, oh, there it is. Oh, okay. Cool. We'll check that next time I run one of these. Yeah, I'm not gonna sit here and chase unicorns. We're basically seeing where it's at. If we see any major issues, we will see what little bits we can do to correct it, because we're at 12:30, which isn't bad. I think we're doing good. We're gonna do some test prints here and get into a real print before we finish off. So, and who knows what else we might run into. So let's go ahead and just, this is, for what it is, this is what it is. And close that, and then we're gonna do a axis shaper calibration, right? Yeah.
And as we start this, one of the other parts of the bleeding edge Calico branch is new input shaper smoothing algorithms. And compared to the discrete shaper algorithms used in Clipper, which are better at handling a single peak and are really good at that, the smoothing input shapers are, again, polynomial functions, which can define a more complex multi-peaked curve and can be better in a wider variety of scenarios. I'm not positive ShakeTune is going to recommend them. I don't know if it's set up to handle them yet, but if not, we can just use the traditional Clipper or the G-code version of the test or measure resonances, I think. And then the Python shaper calibrate script to get those results. ShakeTune can definitely be run on a switch wire.
That peaked out at about 62 dB. I don't know if it's actually catching that, though. It seems louder than that. Hey, Benny. I made a little mount for the ADXL sensor for switchwire to clamp to the front bedpost. It seemed to work pretty well. Okay, so that one
Talking
X
about
is done.
Talking about an accelerometer on the bed there. We also support measuring multiple accelerometers at once during resonance testing, which in most cases you don't need, but you can measure your tool head relative to the overall printer resonance. Because if your whole printer is vibrating at a certain frequency, you don't need to cancel that out. At the tool head, you'll be overcompensating for the vibration as the rest of the printer continues to vibrate. So you can measure your tool head and then your frame, take the difference, and use that for your shaper calibration values.
Now it's doing Y. Ah, it's the front panel. Big time. I needed to put something in there to damp that. Yeah, it's that little bit of play in the slots there.
J-dubs, yes, that is how you'd use it. Most printers, you're not going to see a huge difference enough to really compensate for. But on certain really high-speed printers, you'll see a huge difference when they're designed around the resonances. And at that point, it matters. For mounting one to the motors, there's a specific calibration process using that, and it can give amazing results if you're seeing certain, what's it called? Artifacting in your prints. Where is that?
Clicky clack was clacking, yes. Okay, that one is done. Let it process and see what we end up with. So how would we go about if this doesn't give us the smooth shapers to use? How would we go about figuring out which one to use?
We go back to the standard Clipper documentation or Calico's documentation for shaper measurement.
Okay. Let's go vibration. Nope, input shaper. There we go. It's still processing Y, it looks like. Fresh. Oh, there it goes. Okay, so let's see what we have for X. Ooh.
That is beautiful. Nope, it recommended the smooth shapers right there, so we're good.
Oh yeah, nice. Can I?
Way to go, Fricks. Shake Tune is awesome.
So what is it recommending? For performance, for low vibrations. What do we have here? Smooth EI is 0% vibrations, but the smoothness, what is that? I can't read it and it won't zoom in.
You might download the image and then open it in a separate tab so you can zoom better.
Yeah.
Control 0.
It goes back to 0. There we go.
Yeah.
Why isn't that? Oh, interesting. Okay. Well, let's download that. Open it. No, that's not what I wanted. There we go. Smo, it's recommending smooth EI. Is that correct? What do we have? Smooth EI at only 6,000 max excels. Does that seem right? Is this, do I not have my belt tensions high enough?
Scroll over to the graph again. Let's see what the peak frequencies are like.
I don't really know.
10,000 at the top. At the top left, you have the 1E5.
The what?
Above the top left of the graph.
Oh, yeah. Yeah.
Yeah.
What does that mean?
So that's the peak spectral density. It's just giving you an idea of how large of a scale we're looking at for the peaks here. I think 10,000 is probably decent for now. if you want to go through, do your belts and repeat all of this,
You can
sure.
mess around with it later. Sounds good.
Yeah.
Let's look at Y. Ooh. They both
Oh,
look
that was
clean
Y.
at least. Almost identical. Same recommendation, basically.
Did you open Y twice? That looks the same.
Maybe.
I've done that a few times.
Yes, I did open Y twice, but they do still look very similar. This is X. That was Y before. Yeah, I did. It's funny. That's where I was expecting something around there, but the X, I was a little concerned that X was showing so low of excels, because it usually shows higher. And this one is. But this is still, that's really smooth.
It's odd that the ZV is so low, or yeah, so low there.
Yeah, I wonder what happened there. Oops. Okay. I'm not proficient at reading these, so I mean, I'm hoping just showing it on the screen, anybody who is can draw their own conclusions.
I usually just go with the recommendation at the top.
Mm-hmm. So smoothie.
And then Rhett gets mad and tells me, no, I'm doing it wrong. Go fix this. And then I spend a week rebuilding a printer because I'm chasing unicorns.
Mm-hmm. Well, one thing I am going to do is fix this plate in here better. I don't know what that means as far as how I want to do that, because there's not a lot of room to make any adjustments in there. I don't know if it's a matter of putting maybe something on the inside of the slots to push the panel against.
Just a couple pieces of folded up paper wedged in for now to see.
Yeah. Okay, so we can close this. Now, how do we need to, let's get rid of that, close this and go back to our settings. We go into printer config, a little bit of poster tack in there, some window putty. I don't know, we'll see. Shaper. Let's see if we have anything in here. No. Do we not have a values? Resonance. So we have those. We don't have any values listed. Do we have anything in the bottom?
My puppy's trying to say hi.
Oh. Chris Riley post-it paper. Multiple uses. Okay, what is the syntax for the code section for that stuff? Is it in here? Configuration reference.
So if you want to use the smoothing shapers, those are under the bleeding edge configuration reference.
Is this? Here we go. Input
This
shaper
is the
is what I
normal
want
one.
though, for, right? This is the section I want.
Yes.
So I don't know where I want to put this. I guess I'll put it near the top. Up in here, sure. Input shaper, and then you said in the,
Yeah, under the bleeding edge reference there.
input shaper, shaper type X and Y. They're both going to be the same. Can I just set the one, or does it need to be
If
each?
you're using the same, yes, and it'll just apply to both.
Here, let's do this. Let's just copy this. Put it in here. Shaper type. This was smooth. The I was for both. And then smooth frequency X was downloads. Smooth frequency X was 69.8.
You do have the configuration behind your webcam feed, by the way.
Thank you.
Okay. Perfect.
And Y was 50.6. 0.6. And then damping ratio. This is for Y was 0.063. And for X was 0.057. Okay, that should be good, right?
Looks right to me.
Awesome. Hey, Philippa. Silicone Coxie, you regret it later. Yes. Option damping ratio X is not valid. Oh, is it because, do I have to define them individually for that to be valid? What if I did shaper type individually?
You might have to just remove the damping ratio for the smoothing shapers.
Oh, you don't use it for smoothing?
Yeah, I'm seeing that noted. Note, damping ratios are not currently supported for input smoothers.
Oh, good call. Okay. That means these can just go back to being commented out. These can be commented out.
And then uncomment the standalone shaper type at the top.
Yeah. There we go. Sweet. Okay, so that's done. Reminder for everybody, there are 2 giveaways. One of these colony clacker doors and Polymaker filament. So the link is in the description. Get signed up. How are we doing on people? We need more likes. We're not at 50% like ratio. Okay, so are we at the point where we can do some of these built-in tests?
I think for those bleeding edge tests, you have to add a couple configuration sections, but otherwise, yeah.
Okay. So we have input shaper has been calibrated, and then the PA was the one I wanted to try first.
Yeah.
So there is the smooth, or the nonlinear pressure advance is what it is, this other. So what is this?
So pressure advance is compensation for the fact that when you start extruding, the pressure inside the nozzle does not build instantaneously. You start pushing plastic, it has to melt, and the pressure builds and starts to extrude. So with pressure advance, it starts pushing more plastic at the beginning, so you don't under extrude the beginning of a line. And then as you have that pressure built and you're reaching the end of the line you're printing, it'll start backing off and under extrude it and let the remaining pressure inside your nozzle keep the consistent line width that you want. The standard model is linear. At the beginning, it's a trapezoid. So you start the extrusion and there's an extra boost, a little bit of extra extruded, and then it tapers off. I think the third graph there will show that a little better. Fourth?
This?
Orange.
Oh, linear.
Little more down. That one. So here, the orange is your extrusion. That is your requested flow rate. You go accelerate straight to the full amount, drop down to 0. With the blue, the standard linear pressure advance, it does a really big spike right at the beginning with straight lines. So it accelerates really hard, tapers off to where you're actually requesting, and then drops to the exact inverse. So this works really well if you're just printing lots of straight lines. But you might have noticed that when you're doing corners, like a cube, you'll still get a little bit of corner bulging. And what's happening there, you're printing the line and you come to the end and you have your square corner velocity, which is how fast your printer's allowed to move as it makes that 90-degree angle. The pressure advance isn't taking into account the square corner velocity essentially at that end. So it slows down and the pressure is still built up and it's not compensating correctly for it. So you get a little bit of bulging there before it can accelerate back out of the corner. So when we look at the yellow line here, we see a much sharper and then a tapered off flow there. And then it re-accelerates. So it builds a lot of pressure and then it kind of lets that pressure normalize and extrude. And then as you reach the end of the extrusion, tapers off in response to the acceleration of the printer more.
Okay, cool. So setup. So the best way to tune is to use the tuning macro that's built into the bleeding edge V2. And is this our, is there, okay, what does this say? It says put the macros in tuning tower in their own testing macros file. Set up PA test section. Generally leave size and height alone. So this is what we want right here. It's this.
Just verifying, I'm just making sure the settings there are going to work for your Micron.
Hey, Queasy Diver. Inside, put in your start G code, whether a single print start macro or a sequence of individual G code. Put your start macro here.
That all seems pretty perfect.
Okay. So we're just going to take all of this, copy that, put this in a PA test file, it looks like. PA test. Here. Okay. And then up here, we need to put our print start macro, right? Which is just, I think, print start, correct?
You might need to set your temperatures in there.
Yeah, because it's expecting temperatures from the slicer. How do you, I don't know how to do that.
Put your start G
code here.
The macro you have. So you're going to have print start extruder equals, you're using ABS. What temperature do you want to run that at?
Go 260.
So extruder equals 260, bed equals 110 or whatever you like.
Can I put that up here? No. Extruder
I don't think so.
equals 260. Bed equals 110. And then, oops. And then it probably wants, since we set up materials, right? It probably wants, what is that variable?
Did you add the MPC macros?
I did.
Yeah. Okay.
Actually, let's bring up another copy of the, so I can have the, this under just printer config. Print start down on the bottom. Does it ask for what? Or maybe I can look in the slicer. We go to filaments and advanced. This is called filament type. Is that what it's going to be called?
You'd want to check your printer G-code, start G-code in there, in the slicer.
Yeah, but it's using this filament type. I bet you that's the same. Let's check. Oh, I didn't set up anything in the slicer for this printer yet.
Okay.
I haven't
so
passed
that
it on, but
filament
I think it is just filament type.
The
right?
filament type won't be passed through right now.
Oh, but we could put filament type equals ABS.
Yeah.
Yeah, that's what I was getting at. So it's just filament type, just like that, right? Is that all correct? Do you not have defaults in your print start in case they are not defined explicitly? I don't know. This is a copied configuration.
Personally, I don't put defaults for the bed and extruder temperature because I don't want a default value to be incorrect if I swap from PLA to ABS to PET. Like, or even a nylon or something higher temperature.
Is there anything else I need to do here as far as the way this is set up? It says put your start G code here. Is that
I think that's correct.
Okay. Let's save that. And we need to put PA test into our thing. Can it be at the top here, or does it need to be down lower?
Should be fine here.
Then let's go back down here and look at our start. Print start. Here's the material. MPC material is material. Is that what I wanted to use then?
That's the way I use it in mine. So you would want to go change the filament type.
There's another part. There's another part somewhere where we. Is there a? Do you have to close? Save that and close. But I thought, here it is, MPC. So here's the material. But what is it getting from? How do you pass that on the?
So the defaults are pretty good for ABS.
Well, I was just trying to see how we end up. Oh, I know where. Sorry, I interrupted you. there was a, maybe it was down here. Scroll, here it is. Prusa slicer. Filament type. Oh, material equals. There it is. That's what I was missing. It's material equals filament type. So it is material I should have put over there. I'm closing the loop in my mind on what the value should be. PA test here should be material. And ABS is the filament type.
And after that section, there's another macro, the run PA test.
Mm-hmm.
It looks like this is properly parameterized for your bed and hot end temperature.
Oh.
So if you go back up to where it's calling print start.
Uh-huh.
You can change extruder to bears.hotend_temp. No,
Bears?
leave the extruder equals, but change the 260. Yes, and you'll need to put that in the curly braces.
Then bed equals the same thing.
It's, yeah.
And then material, is that down here?
I don't think that's in those variables. We could add it if you want, but we can just assume ABS for now if you want to leave it easy.
Yeah. And then down here, we want bed temp. We can define this now.
That would be a default.
Huh?
And when you call, those are defaults. And when you call the run PA test macro, you'll have to input them manually anyway. So
so I leave these alone?
Yeah. They were both -1. Cool.
It will ask for them. Okay. Are we ready to try this?
Let's go.
So let's save and restart. I'm wondering how long this is going to take to actually run. I need to load filament first. So let's load filament for the first time in this thing.
Is the acceleration value is still whatever Kyle has set in the default configuration, right?
Oh, yeah. Do I need to change that?
It looks like it's set to 5,000 right now, so it's up to you if you want to update it right now or run the PA testing at 5,000 to start.
Change it. Max velocity. Go and save and restart. Oh, 5-minute drawing warning. Thank you, Bob. I appreciate that. Okay, let's get the hot end preheated. Get this thing loaded. Load filament. So. It's heating up. And going down rabbit holes and detailed configs, it's easy to lose track of time. Absolutely.
Yeah. Especially playing with all the cool new stuff that people haven't seen yet.
tweak it to
We
get it to
haven't
drop
got,
into place.
we haven't gotten to it yet, but one of the steps after input shaper and pressure advance tuning, there's a setting where it will, let me see how they phrase this. This synchronizes the extrusion, the pressure advance applied to the extrusion with the input shaper being applied to the tool head's motion. So that as input shaper is adjusting your movement, this adjusts the pressure advance to match the actual movement that's going to be applied after resonance compensation.
Okay. This spool looks huge. Let's see, first extrusion. There it goes. Nice neat little cone of plastic there. Okay, and then let's get the bed heating up. Get the nozzle cooling back down. There's my tweezers. You know what? Since I see it over here, let's do some hopefully insurance.
Didn't I send you some of my goo?
I don't know. Is that the same stuff that was you mix your own that I got from Maz at Smurf?
Yes, same
Yes.
recipe. So
I haven't actually mixed it yet. I haven't mixed it. I'm gonna give my biased affiliate mention though that there's a Vision Miner affiliate link in the description.
I'm not going to mess with your sponsors too hard.
Oh. I don't think I'm sleeping right. Neck's been bothering me. Okay, that's heating up. That's cooling down. Where are we? There's my tweezers are probably down here. Oh. Working on stuff like this, do you find yourselves having weird dreams about math and physics?
Oh, I missed that one. Yes. So the worst for that, over at Armchair, we designed a printer we call P-Rexy. It's a T-Rex because it has a little tiny cantilever arm sticking out, and the P is for polar. It has a rotational bed. Every printer firmware, Marlin, RepRap, Clipper, if you ever move 200, the physical center of the bed, it crashes. In inverse kinematics, this is what we call a singularity, where it's a point in the mathematical model of the motion with an infinite number of possibilities to exit it. So once you enter a singularity, it's mathematically impossible to solve how to leave it. We mostly fix this in Calico. It's not in the mainline version because no one has a polar printer to test it with. There's only one working P-Rexy in the world right now. But I've had nightmarish dreams about the polar math and the back and forth and all the different conversions and tricks we've had to implement to get that working.
Awesome.
Yes, we basically cheat by never going to 0, 0. We go to 0.0000125 and just offset every move a tenth of a microstep away from bed center. So, something like that.
Okay, let's give away a roll of Polymaker filament. Everybody has 3 seconds to get entered. It's like we are 230 something people. We need to hit 50% likes before I finish this giveaway. We're not there. We're at 101 likes and 237 people. Did you like it, Frank? Did you like that stream yet?
I liked it before it started.
Oh, good. Okay, 3 seconds. Let me get it to the page I need to be at. Okay, published, not accepting the responses. So 3. So I don't know if you've been here. I've been doing this forever. Most people are probably thinking that it's annoying and getting old, but I still like it, so I do it. If I haven't had a new response in 3 seconds, then we close it. But every time we have a new response, then I start the 3-second counter over, right? So this is the idea, to make sure everybody who wants to be involved can get involved. And then we have a certain number of people who have decided to make it a game and see if they can get in as the last person entered. Have you entered for
I did not.
Polymaker filament? You should. Link is in the description.
Okay. I was trying to be... I don't know, it feels weird for me to enter.
I feel the same way. I very rarely enter anything. But we've had several since we've been talking about that, so I'm going to start the counter over. And I'm sure we'll have to start over again when you enter yours. So 3, 2.
There you are. Happy?
Yep, there it is. I just saw it. 3, 2, 1. 3, 3, 2, 1, half. Now we get serious. So the voice changes. Once I'm done counting over, we start doing the voice change because we got a new one there. So it's 3, you know, the dad voice starts coming out. 2, 3, 2, 1, done. Who do we got? Where did we get to with the build? It's homing. It's many things are calibrated. We're getting ready to do our first print test. Let's create a spreadsheet. Okay, who got in there first? What do we got? GJ is first. Who got in the last one? You were like the 7th from last. Max got in last. Okay. How many times do I shuffle this, Frank? Number between something and something.
7.
No, 1 and 7. Number between 1 and 7, people. $42 is not between 1 and 7. Orange is barely between 1 and 7. But I did orange just a couple of times ago. J-Dubs, you said 3. We're going to do 3. 1, 2, 3, spin. Polymaker filament. Who do we got? A Casher Patel? Are you here? You have 2 minutes to say something in chat. Casher Patel. A Cash R Patel. Are you here? Yeah, I make people be here. So I always do it at 1 my time, So consistent time. Hey, Casher Patel. Are you here? That's doing that. That's doing that. Technically 4 is the number between 1 and 7. It is. Hey, Casher Patel. Oops, I didn't actually hit the timer. You get extra time, apparently. Oh.
But while we're waiting,
Yeah.
Troy asked if we have to keep the gantry in the polar printer or the nozzle right over the center of the bed. Yes, it must be perfectly aligned to the center of rotation, not the actual physical center of the bed. We made that mistake early on and tried to use printed parts to align the center. That it is impossible to print a perfect circle that doesn't offset the center of rotation. So there's a whole alignment process to get your gantry.
Interesting.
I don't remember what the trigonometry term for it is, but aligned precisely to that center. As for Bob, the slicer profile doesn't matter. Calico just looks at a standard Cartesian G-code and converts it to polar inside the inverse kinematics.
Kusurya, thank you for the gifted memberships, and Raj, thanks for being a member. Hey, Kasher Patel, you have way more than 2 minutes, but you had way more than 2 minutes. You only have 20 seconds left to
Admiral
respond.
Adama, the benefit is someone told us we couldn't make it work, and then we did.
Yep.
It started as a joke in a side thread off of a Voron vendor channel and went way too far.
Let's do a number real quick. 1 and 10. 1 to 10. 1 to 10. We need to shuffle this again. 1 to 10. 3D Printcraft UK, thanks for being a member. Yep, A. Kasher Patel is a Polar TED Club member. Are you aware of the Polar TED Club, Frank?
I am not.
Yeah? So, user used to go by Polar TED in chat. Wasn't here for a Trident kit giveaway. Was off having a burrito or sandwich or whatever. Then they came back. And I'd already given it away to someone else. Jason was in chat and ended up sending them a V0 kit as a consolation prize.
Jason's
it was a very fun little stream there. Maker Viking says 6.9, so we'll do 7. 1, 2, 3, 4, 5, 6, 7, spin. Did we go through? We have gone through many of them. You know, Counter Potato, please be here. You have 2 minutes to say something. Counter Potato, congratulations. This time I actually hit the button. Huh?
David asked, what was the PA macro being set up? This is a non-linear pressure advance, different from the normal Clipper version. And there's a built-in macro and calibration process for it that you just set up a little bit of extra macros around to interface with your normal print start. And then you can just run the PA test from within Calico.
Counter Potato, where you at? Congratulations, but you got to be here. Wow. I think this is the first time my concurrent viewers has gone down in the middle of giveaways. There you are.
Oh,
congrats, Counter
I see
Potato. Congratulations. Let me go look this up real quick. See. There you are. Over to the email, get this sent out to you. There's that. And
Counter Potato wants to make sure it's okay to win something twice on your streams.
win something twice on my streams.
Sounds like
this is my
once.
second win. Second win here, or second win in how long? Second win in how long? And is it the same like Polymaker? I wouldn't be surprised if there's like a, it's been a while. Yeah, well, don't worry about it. You're fine. If you have any trouble with this, shoot me a message, but you should have an email in a second. So congrats, Counter Potato. It's been a while. That's not a problem. Yep, it's all good. Okay, so let's do the Colony Clacker door kit. Colony Clacker door kit. This is US only, remember. US address only. Don't stretch it. And we'll give 3 seconds to get this in. Everybody's had plenty of time, so this is a real count of 3. So 3. Did you want a Colony Clacker door kit? Did you enter?
I did enter.
Of course you do. You need a Micron in your life. I won't tell Rachel.
So it's almost the Doom Fork design that I have used the Micron Doom conversion parts.
Okay.
So it should actually fit a Micron 180 door.
Okay.
But worst case, I re-gift it to a community member with a Micron in need.
There you go. There you go. We haven't had any in that whole little chat, so we're going to do the final countdown here. 3, 2, 1, and done. Nope, we just got one right before I click save. 3, 2, 1, done. Okay. Who was that last entry? So Cybertech in there first. Mtalo. Last one. Okay. What's our number range this time?
9.
9. Number between 1 and 9.
3 to 9.
Huh?
3 to 9.
Oh, 3 to 9. We need 3 to 9. 3 to 9. I think Oscar has remembered that there were no treats yet today. Let's see. Andrew, you said green. We're going to go green. Green, spin. Who do we got? Colony Clacker door kit looks like JW. JW Slaughter, are you here? JW Slaughter, you have 2 minutes to say something. JW Slaughter. Are you here? JW Slaughter. JW Slaughter.
I believe he has changed his profile name since the stream started, but he is there.
It's what?
I think he changed his YouTube profile name since this started.
How do you know they're here? Did they say something? I am here.
Yes.
J-Dubs?
It is J-Dubs.
The icon is JW. So J-Dubs, yep. You gotta put your...
I know who that is, though. I can vouch for them.
Well, here we've got a fallback. We've got a extra check. So what is the number you put into the form when you put your entry in? Now that JW helps the case. There you go. We got it. You're good. Congratulations, J Dobbs, aka JW Slaughter. Congrats. You will receive an email from Jason. I will pass your information on to Jason. He will contact you, and that. There is probably a greater than 33% chance of that, Angie, or Angel.
Yes. I always put 42.
Mm-hmm. Yep. Okay,
Or 27.
Let's unpin that. 27 is a common number for people, or 72. 72 is a big one I've seen.
27 is 3 to the third.
What is it about
It's a-
72? It's volume of a cube. you're 3 to a third.
That one, I'm not sure about 72.
Yeah, I've seen that a lot. Edit. Let's delete the giveaways. I forgot to delete these links last week.
6 dozen.
See you, Andres. 27 backwards is 72. Look at this guy. He's just getting comfortable now. He's just waiting to hit the keyboard. Okay, where are we at? We're gonna actually run this because this thing has been warmed up. It's been warm. That was a good little break to let the printer warm up. So the real quick, I know I'm killing chamber temp here, but just making sure there's no thing there. So now we actually run this. There's a command, right? PA test macro will run.
You'll run that run PA test.
Run PA test. Where was that?
Just a tiny bit up now. Too far.
Oh, yeah, that there. But is that all you do? Is just run PA test? No.
If you go to fluid and click the little drop down on the command or on the macro on the left,
it'll be here. Run PA test.
it'll give you the fields you can fill out.
Ah. So this one's a nozzle size.
Yes.
Target temp. Our PA value, is there? Do we know what that needs to be? PA value, used for further tuning of PA value. If the PA value is not 0, then the tested PA value will only be around that variable.
So that's like running the
memberships.
lower or the higher resolution second set of PA tests.
So if I leave these, they'll take the default, right?
Yes.
So leave that. Leave. Oh, it actually picked up a different PA range than, I mean, as a default here, than is in the. It says 0.03 is what I copied into the config. Where did it get?
So if you
that?
look at the set G code variable line within the macro body, scroll to the end of that. Nope. Yeah. So it has the for default. Fluid is parsing that section of the macro to set up those inputs.
What would you use as a range here? Hey, Amber. Oh, do we have our raiders coming in? We have our 3D Musketeers raiders coming in. Then flow rate. What is flow rate? Flow rate doesn't have an explanation.
Direct drive 0.01 is probably solid.
For PA range?
Or the 0.001, like the default there, works.
Do you know what flow rate should be?
I think if it's left unset, it uses a same default.
It's set to -1. The default here is -1. And the variable flow rate is -1 here. Hey, Grant. Welcome, Musketeers.
Okay, so there's a little more we need to set. If you hit the tuning procedure, direct drive.
Oh, direct drive. Install Calico. Set up. Set input shaping. In your printer configuration, set your pressure advanced model. Oh, that's it, huh?
Yep. So you need to add the enabled extruders extruder to the input shaper section.
Set up input shaper on you.
And that's what I was talking about, where it synchronizes your pressure advance with the compensation from input shaper.
Okay. So we're gonna go here and we're gonna change some things. So in the input shaper here, is that what it was? Well, extruder is extruder. Set up input shaper. Is that where it goes? It doesn't tell me where it goes.
I'm double checking which section that goes in. Some of the bleeding edge documentation is still in progress.
Mm-hmm. It's fine. In your printer configuration, set your pressure advance model.
So the pressure advance model goes in the extruder section.
Okay. Did this other one go in the input shaper section?
The enabled extruders does, yes.
Okay. And then we go down to our extruder section. Okay. And this one gets in the pressure advance section, gets pressure advance model. Do we know what one or how we would determine which model we want?
The 10H is the more universal option. You can calibrate both and then compare the differences in your prints visually to see if one is doing better than the other. But
it says pressure advance model 210H, linear advance to 0, and nonlinear offset to 0. Is that all in the extruder?
Yes.
Linear advance. What? Linear advance to 0. There is no linear advance. It's pressure advance.
You add, I believe you get rid of the pressure advance. Comment that out.
Okay.
And then you'll add the other values.
Is this stuff going to show up in here?
It's not in the normal configuration reference.
It's not. Where was the leading edge? Was it in here?
It's on, there's the separate nonlinear pressure advance section of documentation with all those
that's where
new
it just
things.
was.
Yeah. I don't see them documented anywhere else. I'm noting we need.
Are they even documented in here on what section these go in? Because that's
they go in extruder.
Okay.
Those 4 fields will all go into the extruder section.
Okay. Let's just copy this whole block. Linear advance to 0. Nonlinear offset to 0. Linearization velocity to 1. And pressure advance smooth time, which we already have up there. So we can delete that. 0.02. There? And do we want to comment out pressure advance, or just was that okay to leave it?
I believe you commented out. It looks like if not, it won't be read and it will config error.
Yeah, sorry, I was not scrolled right.
So the
Okay.
change that was made in bleeding edge, the pressure advance model defaults to a value of linear, which then loads a specific linear model that reads the pressure advance configuration option. So when you change the model, it's not going to read that option anymore, and Calico will complain there's an unused configuration option.
Got it. So then run the PA test macro with nozzle set to your nozzle diameter, target temp set to your, and test param of 1 to vary the nonlinear offset. Oh, so this is actually going to print a tower. Okay. Run the PA test macro with your and a test param of 0 to vary the linear advance. What is the difference there?
I'm having to read the code to understand this model.
Okay, so we're going to run this at 0, 1, and 2, it looks like, and then evaluate them. So are we ready to just run this so we can get it started?
Let's start it and chat while it goes.
Yeah. One thing I'm noticing. Oops, that's not what I want. Those back up and running. Then I think this should do all of the start print stuff all on its own, right? Not actually done that, so let's
It should, yes.
Nozzle 0.4, target temp 260, bed temp 10, PA value 0. It didn't say anything about flow rate. I don't know what to put for flow rate. Oops. There's no search result for flow rate.
All right, if it's -1,
Mm-hmm.
it'll just use whatever you have set as your flow rate here in fluid. So it'll stay at 100%. That's what we want.
Okay. So we're going to send. Gonna see what it ends up doing. So it's gonna home. It's gonna do QGL. I think test param 0 is what we run first, right?
Looking at the actual implementation of the kinematics, yes. Without that set, we're not going to see a difference in the other ones.
What happened? What happened? Probe sample exceeds tolerance.
Try just running quad gantry level again manually. Is the hot end hot right now?
Yeah, it's at 150.
They're saying it triggered when you moved the printer.
Oh, okay.
That makes sense.
Yep. Okay, well, it'll take fewer cycles next time when I actually run this again. So far, things are working well, Neil.
Yeah.
Okay, so all of this is set. I'm just going to rerun the test. So it should do its whole thing. Go ahead. Zoom in more. There we go.
Admiral, yes. For features pulled into upstream Clipper, the biggest one I can think of right now is adaptive bed meshing.
I keep bumping things. I'm gonna sit back, hands behind my back, in my pockets, and let this finish its... Oh, well, it's now not homing.
Oh.
No trigger on Z after full movement.
Can you feel if the tool head feels like there's any vibration from the fan?
Okay. That would mean it's... No, it's something else is set up because it's not even touching and it's moving. It's not triggering is the problem. It's moving further than it wants to and it's not triggering. So there's something out of whack as far as where it thinks it is. What is... I want to look at this. I want to actually be able to see down here.
Bob is asking, that's Fusion's Atomic Sunset Orange, right?
This is Fusion's Sunforged Orange, but it's their gloss line. They have a matte line version called Sunfire Helix that's the same thing but in matte. This one isn't available yet. So this is doing the first probe fine, and then it's moving up and out of the way, and it's not triggering at all. It's moving too far before it triggers. So it's on the second probe that it's, which is really weird. And it's only after we've made any of these changes and it's heated up. No trigger on Z after full movement. But what is it here? Let's go into here, and if we go into the probe section, PZ probe. PZ, here we are, PZ probe. So sample retract distance. Did you print anything before this point? No, we haven't printed anything. Why is it in the printer config under the Z? Second homing speed is 3. Homing retract distance is 3. Any thoughts?
So it probes, it retracts, and then it probes and crashes into the bed.
No, it's saying it's moved too far. So it's like it's retracting further than it thinks. No, it's not it's not activating at all on the second thing, and it's stopping because it's moved too far, but it hasn't even touched the bed yet.
If we watch closely, does it actually hit the bed, the first probe?
Yes.
Okay.
Yeah. That's what I was getting down here to look at. It's the first probe, and I'll double check here. And maybe we can get everybody a little bit of a view here. You'll be able to see, let's see, there we go. You'll be able to see the nozzle and the PZ board. So you'll be able to see it trigger. So I think triggers. Oh, so it probed on its own just fine. Here, let's do a home all. It's gonna come down. Oh, well now it's, okay. So maybe it did trigger. Oops, sorry. Maybe it did trigger before. So I'm gonna do the very simple thing. So I'm gonna go to the next sensitivity value and try this again.
You might want to go up and finger tap it to make sure it doesn't plunge your bed.
It's triggering.
Okay.
The difference, I can see it's triggering just with movements. So there we go. Okay.
Cool.
Let's try running that thing again. How many times is this? Oh, and I lost all my default values here. I got to re-enter them. Okay, send. We did do all the probe stuff. It's just a matter of sensitivity testing now, and you just need to do that cold and hot. I mean, you start cold, and it's probably going to need changes when hot, and that's apparently what was needed here.
And the PZ probe is very sensitive. On my V0, the fans are enough to trigger it, and it took me weeks to get it tuned so I could actually probe while the fans were on. I ended up changing all the fans out, and it's not as much of an issue now, but...
We're at 54-degree chamber temperature right now. Feeling pretty good about that. Okay, now what's it doing? Bed mesh? Yep, okay. Josh, this is a fusion filament. Their closest that you can get is called Sunfire Helix on their site. It's probably out of stock since the first stream in this series.
Yeah.
That's the matte version. They have two series of ABS. So Fusion has two series, a gloss and a matte. This is the gloss version of their Sunfire Helix. Is that Sunfire Helix or is that Sunforged
This is
Orange?
Helix. This is the matte, I believe.
Yeah. Yeah. Yep.
Yep. It's my favorite plastic, personally. So not
That
necessarily
particular
that color, but
oh, but Fusion.
I like the color. But where's their geomagnetic mauve?
Yes, that's a great
Ends
color.
up on everything I print.
Will I be uploading the back cable cover between the A and B? Yes, I just need to put it out on my GitHub.
Now I have something around here.
Hey, John. You knocked out of hair, not fun.
Spare parts bin. There we go.
Oh, yeah. Okay, now what's it gonna do? It should. I don't want that to save. So let's cancel that. Okay, now it's heating up the nozzle. Why are the Z motors facing the wrong direction? Not sure what you mean there. Meow. It's geomagnetic meow. Where did Oscar go? No treats, I'll pout over here. Okay. Oh, I better get a real good look at this. Let's go. Oh, it's should go down a bit. Sorry, I'm in the way, but I gotta see this first layer. It's really hard to see the black filament on black textured plate, how well it's squishing or not.
GPs, yes, there's a chamber thermistor under the rear extrusion.
That little shiny spot in the back next to the Z cable chain. That little shiny spot is the thermistor sticking up. So I think I've just effectively canceled out the offset that I set on the Z end stop calibrate, the probe calibrate. Because I think that was 0.07 and I've set this to minus 0.07. but it's printing. Current chamber temp is 52 degrees.
I have no clue how long this test will take.
Oh
I
yeah?
just realized that.
If this is our temp, or if this is our print for the day, I'm okay with that.
Okay. Is it giving progress updates in print status anywhere?
Here.
Or does it just not show that a print is running at all?
Console. Starting the tuning test. Pressure advanced model. There we go. That's the whole thing that we see right now.
Okay.
110 C bed, yep. It's just printing what, I mean, it would be like a brim. But this said it's a tower. Is it going to actually?
It generates a brim and then the tower, looking at this.
Do we expect that tower to be fairly? Oh, now it's changed. Did it change? Nothing between those two. It's not changed anything in that report.
I'm reading through how this generates the tower.
Oh, there it goes. Got a.
Oh.
It just needed a really big brim.
So if you go to the home screen on Clipper screen there, what is it? Or on Fluid, does it show anything at the top? Yeah, it has a 1% there, perfect.
What's the
Top left?
Oh, progress.
Yeah.
It says, okay, it did say 3.5 hours.
I think it'll be faster than that, but
yeah, it's already bumping down to 2.5.
yes, GPs. It's a single wall tower. And as you can see, it's doing like a stuttered, like quick acceleration out of the corner to a near stop in the middle, accelerating back to the end there, and then the square corners. And this is specifically tuning the nonlinear pressure advance that is supposed to reduce the rounded corners you'll find when printing at high speeds with the standard pressure advance options. What should we expect? Let me pull up the... There's pictures somewhere.
Yeah.
You want to switch back to the example or the documentation for doing this?
So if we go down here, we'll start seeing some of the example pictures.
So that first one is without input shaping. And you can see there's kind of the point where the center bulges smooth. And then if you look closely on the far right side, as it goes up, the rounding around the corner gets much less until it's somewhere around 2/3 of the way towards the top. It looks pretty smooth as it corners.
Yeah, we'll go through those as we... I don't know how long this is going to take to print.
It's already at 9%, so it's picking up speed.
Yeah. Oscar's making sure everything's going okay. Wondering where the treats are. Yeah, while that's running, let's do some treats. I think that's a good idea. You want a treat? Yeah?
Yes, input shaper has been ran. Got decent results with the smooth shaper options in the bleeding edge. So with luck, we won't see any ringing around all of those.
What's that?
With any luck, we shouldn't see ringing around the corners, just...
I thought this one turns off input shaper.
Does this part?
I think 0 turns off all.
Did I misread things?
One more? One more? You get it up here? Right here? You want it? You want a treat? There you go. 2 treats. Last one. Lick, lick, bite. Lick, lick, bite. Lick, lick, bite. Lick, lick, bite. Yep, yep. 3 licks that time. Yep. Okay. Oh. Fix the Apple logo on the collar, it's crooked. It is. I'll fix you later. Oh. What is the percentage on this thing? 17%. What else? Are there any other bleeding edge features or whatever that we would be covering here? I think that's the ones, right?
I think we about covered the bleeding edge start parts.
And we covered a lot of the other changes. The chamber is at 53 right now.
A couple of my personal favorite things we haven't talked about. They're a bit more macro developer focused, but you can reload your macros, just the definitions, without a full system restart. So if you're just iterating on a particular macro, instead of hitting save and restart every time you edit it, you can just save and then execute reload G-code macros. That's its own command.
Oh, okay.
And it just reloads the source and you can keep going.
Without having to rehome and all that kind of stuff. Yeah.
Yep. Save config has a restart equals 0 option, which
Okay.
will save your configuration again without restarting, so you can make small tweaks and save values without having to rehome after. I'm sure you've had it where you hit print start, you notice your temperature is wrong, but you'd have to wait till it finishes heating up before you could cancel it. So you just hit emergency stop.
Right.
Instead, there's heater interrupt as a command, which just cancels everything that's happening while it's heating without a full shutdown.
Is that listed in here? Heater interrupt?
Yes, it's under heaters, fan, and PID changes.
Ah. Model predictive
Right
control,
middle.
velocity PID. Heater interrupt will interrupt a temperature wait. Cool.
Right above that, there's the PID profiles.
Mm-hmm.
You don't really need this with model predictive control, but you can calibrate PID for, let's say, your 210 for PLA, 260 for ABS, and have both profiles saved, and then a macro to load, I'm printing PLA this time, I'm printing ABS this time, and have specific profiles for maybe fan off, fan on.
To do some different fan controls, it looks like.
Yep. Those are mostly useful for heated fans.
Mm-hmm.
Actively heating things, which don't know how much you talked about on stream here.
We would like to talk about it more. I just have to have the project to make it safe and, you know.
So those are more for active chamber heating.
Yep.
Which, dangerous if you're not cautious about it, but these help you do it a bit more safely. The next one, the driver CS and current range values for TMC drivers.
Oh. Mm-hmm.
These are internal fields in your stepper drivers that Klipper does a pretty good job of setting for you, but you can't always get a perfect value. Every control board has what we call a shunt resistor. And that's a resistor that drops the voltage being given to the motor in a place where the stepper driver can measure the outgoing current the motor is pulling. And that allows it to do a lot of its internal adjustments to make sure your motors are running correctly. The problem is those shunt resistors are supposed to be sized specific to the motors that you're going to run. But they're non-replaceable on our control boards, so all of the vendors, they just pick a value that's pretty good for a wider range of motors that are on the market.
Okay.
But we can't adjust them ourselves to get the precise values, so we get a good enough value for the driver. CS is the current share. And that's basically how much or how the driver is controlling the output current. And sometimes for very, very specific scenarios, you might need to manually adjust that.
Okay.
For macro developers, the do extension is really nice if you need to just add values to a list or something. If you want to get fancy and have sine and trigonometry, the math library, which gives you pi and sine and cosine and a bunch of other little things, is available. There's reload G-code macros there. And then not many people have used this yet. I love it. You can write your macros in Python, not using templates anymore. And then we have official support for plugins and try to internally stabilize our APIs a little more because we want your external plugins to just work. without breaking changes all the time.
For the G-code macros written in Python, what's something you do? Can you think of anything you can do with that that would have been difficult before?
So, you know how when you're writing a macro template, the entire template is rendered the moment you call it. So you can't react to changes over time. Like your print start can't say, start heating the bed, and then later on, after a bunch of stuff happens, if the bed temperature has reached this point, do this. That's just not possible with a macro template. Python macros are evaluated line by line like Python normally would be. So if you have, for example, 4 heaters, multiple sections of your bed, you can iteratively heat those one at a time. And a single macro call can watch for each, like, what if heater 1 has reached temperature, start heating heater 2, and cycle through them in real time. Morton is saying the squiggly purge, which gives you a little sinusoidal purge line, is much easier to implement in Python. There are some things that are available in Python that are not at all in a regular macro, like waiting until a condition occurs. So you can just kind of pause execution like a heater wait, where when Clipper says wait until this temperature sensor reaches this point, in Python you can do that, but with any condition you might want. Yes, GPs, that's exactly where I'm using it.
Yeah, I'm noticing that too. Neil, the belt artifacts there, little vertical lines. We'll get a closer look at that when the print's done. Only 42%. I don't think we're going to make it through more than this one. So we're at 4 hours here already.
Those artifacts, J-dubs, you can see they're perfectly aligned vertically each time. Those are typically something like a pulley in your belt path, causing a slight offset each time the belt ticks past that tooth.
These can also be tuned with just belt tensions and do you run the chopper tuning add-on to tune your motors? What is the chopper tuning add-on?
You remember when we had RCF super glue the accelerometers to the motors on his Phoenix?
Oh yeah. Mm-hmm.
It's using an accelerometer to measure the vibrations of the motor and then compensating for it. And you can do manual chopper tuning with some of those internal stepper driver values like the CS, and I'm trying to remember all the possible things that feed into that. Trinamics has some Excel sheets for most of their drivers that help you through some of that tuning. But the chopper tuning add-on has you use an acceleration to measure those vibrations instead.
Is that along the same lines as the TMC auto tune stuff?
It's like the next step after auto tune.
Oh, okay.
Auto tune is everything that Trinamic published in those Excel sheets just automatically handled for you.
Mm.
The accelerometer chopper tuning is the step you run after that.
Okay. What's the best way to what is I mean, super gluing accelerometers to the steppers doesn't sound like a wonderful thing. Is that the best solution for that?
I've seen a few printed mounts that you take two of the two of the screws that go through your entire stepper out and mount an accelerometer to the bottom of the stepper.
And is this you test it and set values and then remove it, or do you leave it on there?
Yeah. And theoretically, the values are going to be consistent across that motor with that driver and control board. So like the values that we find for Phoenix, if they're using the completely stock build, we can share, and almost everyone that builds a Phoenix using those parts can just use those values. Except we're changing everything now. So
yes. It's printing though. It's exciting. Putting down plastic. It will have done, this will have been a longer print than it is printed total before this.
little belt tension, but it doesn't look bad. Yeah, I haven't seen that newer chopper tuning you're mentioning there, GP. I'd love to look at that.
Looks like GP's gonna post this in my Discord.
Which Discord are you dropping that in?
So are you on mine? Links in the description. Here, I can copy the link and put it into chat. Huh?
I'm on yours.
Let's see what this says. Semi-automatic calibration of driver parameters. Install the calibration script.
Okay, this is the one with the accelerometer, though, I thought.
Connect the accelerometer to the motor by screwing it in. Oh, it's screwing in. However, it is possible to connect, as for example, in measuring resonance for input shaper to the print head or bed. This method may give incorrect data if the mechanics are crooked, but on properly assembled printers, it's not inferior to the first. Interesting. So we should be able to run this on this printer and get some return data.
Yeah. I think this is one where you'll want to go through all of the shake tune steps and get your belts better and everything perfect first.
Yep. Yep. GPs is saying hadn't had problems with just using the toolhead ADXL. That'd be nice to not have to figure out mounting on steppers.
I think someone was talking about making a magnetic encoder plus accelerometer in a NEMA 17 profile.
Mm-hmm.
So you can just bolt it onto any stepper and turn it into a basically servo, but also be able to have the accelerometer there. Who was that?
Oh, bed fans aren't running. Filter fan? Is the filter fan running? Is the filter fan running? Filter fan is not running. I kind of want it to be running. I don't want to be sitting underneath the...
Are those set up in your print start already?
I might not have turned everything on. Turn the filter fan on at least so those parts don't. Or is that bed fans? No. Maybe those are running. The filter fan wasn't, but I think the bed fans might have been running. We're at 54 degrees, by the way, now in the chamber.
Without bed fans, that's awesome.
Well, it's really hard to tell if they're... I thought they weren't running a second. Let's turn the filter off. No, bed fans were not running. But if I turn filter fans on, the bed fans are turning on. Yeah, so that's without bed fans. So I've got some configuration things to look at. And as the beds turn on, it's already at 55 degrees. So...
Morton, what are you sending me to work on this morning?
But why isn't the filter turning on? The filter. Probably the ports I'm plugged into aren't configured in everything correctly.
Yes, the
50.
dual loop PID control. You want to explain that for me real quick?
Melty, I know, I don't want a melty fan housing. Uh-oh. You still there?
Me?
Yeah, okay. Just making sure I could hear you. One of my AirPods is getting low on battery, so I put it in the charger so I can swap them back and forth now. Yeah, it's at 57 now, Neil. Turning the bed fans on makes quite a difference. Now, it is blowing air to the back and up the back panel, so I think we're gonna probably see a little bit of a false high temperature there.
I mean, with the circulation, you get a decent blend.
Yeah. And it might be one of those where we see this spike.
Yeah. Okay. So Morton sent a pull request for a new feature this morning. using a separate sensor on the bed to measure the actual bed temperature. So then it PID loops the heater of the bed higher and uses that second thermistor on the bed to actually measure where the bed's at to get a better control loop around the bed temperature instead of just the sensor on the heater.
So what is the difference between that and just using that second sensor and ignoring the one on the heater?
Probably better control so you don't overshoot the safe limits of the heater on the bed.
That you control the power to the heater and can limit it better. Okay. So what's the ideal location of a thermistor in one of these beds?
I could see like putting a channel under your flex plate to embed a glass bead. I'm curious to see the options though.
Yeah. And what's a practical, good enough rework on an existing setup?
Okay, so just on the side or in the middle. Which printer is going to be easiest for me to stick a top thermistor on? I want to stick like 3 extra thermistors on the bed, one at the edge, and then one top center right under the flex plate. Measure the difference now and see what kind of results we get.
Or 58C now, chamber temp. We're 81% done.
Next, we figure out how to measure and read the results of this correctly.
Yes. If you have one with little wings for bed stops, use an M3 thermistor screwed in there from the bottom. I have that. Exactly on this printer. And I have M3 thermistors. I may even have an M3 PT1000 thermistor.
There's next week's video.
Next week's video is playing with box turtle stuff. Installing an enclosure is the main part, but working on that Jabberwocky tool head otherwise. I gotta get stuff printing on that. And I have to figure out how I'm going to implement Revo PZ into the Jabberwocky. Not the PZ Voron, just their washer, the standalone sensor. Because I don't want to use, and I don't have any of their default probing solutions. And getting some experience with just that washer would open up to using a bunch of different hot ends, different printers.
What probes do they support for Jabberwocky?
Hmm?
What do they support for the Jabberwocky? What are the options there?
The scanning probes.
Okay.
Cartographer beacon. Someone did a user mod to install a Revo in there, but it doesn't have a channel for the PZ cable, and they didn't publish any CAD for it. So, does the washer sit between the cold end and the printed part? It could, the GPs, but one of E3D's examples is just putting it on the mounting screw between the roto and the X carriage, just somewhere solid that a force can be detected at. They recommend using washers to either side of it, so you get a even pressure on the PZ element and go from there. So one thing is I want to see how much you can detect on the like putting it on a bed screw on a V2. Put it on one of the bed mounting screws. See if you can get away with one detecting a probe at any point on the bed.
I do have a spare PZ. Stop giving me new projects.
I mean, it's pretty incredible how sensitive these things are. So it'd be interesting to see how far you can take that. It's this guy. Look at that focus.
Mm-hmm.
But yes, I was looking at ways of putting it between the cold side and the printed part on the Jabberwocky. They use that bamboo style hot end.
I've got so many hot ends.
This is pretty good. This is reaching nearly, and it's fairly chilly in my garage here. I've got the AC going, and it's 58.5 degrees chamber temp. This is almost done. Has anyone tried putting 4 of them on the bed mounts? It's an expensive proposition there.
I have seen, well before Revo PZ, attempts at doing piezo bed mounting. And part of what makes PZ nice and actually special is their filtering algorithms.
Yes.
That's where every piezo probing project failed before E3D got one that actually works well.
I think, what are they? These cost $60, $50 or $60 each? I have no idea,
Something
actually.
like that.
Oh, my stomach is growling.
It's €35
Oh, okay. That's a lot less than
for
I
the washer and sensor board.
79 for the cold kit, but that's a Revo Voron or PZ, Voron PZ or whatever. 79. The
that
washer.
One is just the washer version.
Yeah, but you would want just the washer version if you're trying to experiments. It finished. It finished, and is just sitting there.
It did not call the print end, I guess. Did we miss something in the macro setup? I would just go to the console and run your print end macro real quick.
Oh. Print end. Yeah, because it's doing. Oh, that would be.
Oh, yep.
There.
If you look in the configuration on the documentation, they
had a
call
thing
it
to
end_print.
What
not
is it?
print_end.
Ah. Where is that? Or was that? P8, is it in? It's right here, right? Print start. And then where did it call it? End print. PA test and print. Is that what it's actually? I guess it has to be because it did it. Print start, print end. Yep. Okay. Okay. That was cat stuff. So let's go there. Go here. The guys are out. Let's look at this. Oh, just take the whole thing. Does that include the electronics? Yes, it should. So it didn't print very centered. I wonder if that's something I need to go in and look at. But,
origin X, origin Y.
Yeah. What am I looking for the point where these are?
We're looking for where they look the best on both sides.
On the front and the back? Or on the sides?
And that was test parameter 0 or 1?
Yeah, let's go look at. This was 0. So it says run test param 0. Evaluate the tower looking primarily at the front side. Evaluate here. Primarily at the front side. Evaluate the ideal linear advance based on the height that looks best there and the factor from the test macro. Switch ears. Can I hear you? Can you talk?
Yep. Am I here?
I can hear you.
Sorry.
So, no, I just want to make sure when I switched ears, because I don't have any other feedback from the headphones. Write down that value, but set the configuration to 80% of that and restart. What does that mean? So if I'm looking at the front of this,
we're going to measure where it looks the best.
I don't know what the best means. Looking at this.
Looking at their examples. Look at the left side.
Looks very uniform over there. looking at the center features mostly.
So I think what we want for this first one is on the front.
Mm-hmm.
On the right side, we can see where it kind of converges and looks decent. And then on the left side where it does. So we want to measure the height somewhere
Like
in the
up
middle
here?
of those two. Yeah.
And just with a ruler?
Yep.
Where would you say it looks good?
My gut is saying about 44. Kind of gives us a somewhat uniform across.
Oh, you're talking about where it looks about the same all the way across these things?
Yeah, somewhat similar there.
Yeah. So if that's 44, how does that translate into?
So we take the 44, and what was the
0.01.
parameters? What parameters did we give?
It was 0.01, right?
I think so.
I think it was the default. Go back here.
So then we have what, 0.44 as the value?
Yeah. So PA value would be 0.44 now. So here, if we go here then, so we set it to 0. Evaluate. Now run the PA test macro with your nozzle diameter, your intended hot end temperature, and a test parameter of 1. So you don't change anything else here. We just write that down. So 0.44. Ooh. That really stuck. So we just write that down and then we run it with 1.
It says write down that value, but set the configuration to 80% of the value.
Oh, I see. Oops.
So we want to set the linear advance to 0.352.
Set the configuration. Okay. So then we go over here, and I guess it's here, right? And
Be the
top.
extruder section.
Extruder section. And linear advance.
Scroll
there?
just a little further so we can see configuration. Yep.
Oh, sorry. Thank
Yes. So
you.
the
So
linear
this should
advance,
be 0.44 times 0.8.
which I get 0.352.
0.352. Thank you. 0.352. And save and run it with param 1.
Yes. Yeah, GPs. This first one, it doesn't look great. You set the linear advance and then run this for... We are looking for the nonlinear offset next, which gives us the start versus the end of the pressure advance adjustments.
That's it? We don't set a PA value, right? Because that's in
Nope.
the config. Let's see what this... Oh. Okay, well, at temperature, I gotta retune sensorless homing at temperature.
Too sensitive.
Mm-hmm. That's okay. This is, once it's set, it'll work. All you people who say micro switches are better, yes, I'm not going to argue against that.
Neither will I.
Yeah. Okay, so we need to get this back up to temperature.
Sensorless is convenient when I don't want to run wires everywhere.
Mm-hmm. Okay, so let's get this. We are operating in chamber temp drop to 48. I'll argue they both suck in their own way. Yeah.
Yeah.
Okay, how far back can I go? There we go.
Clickie's all right, but I love my beacons.
So let's just try a value of 3 on these then, right? It's less sensitive. Let's move this thing to the middle. So I just set my SGT value to 3 for both. And let's see, our chamber temp is probably, I mean, it failed on the last one. So let's, okay. That's fine. So now I want to see how this PA test behaves. So, there we go. 24, 260, 10, gram 1, send. There we go.
Yeah, Steven, when the micro switch breaks and your homing crashes, but if you set your homing current lower, the same as if you're doing sensorless, you're just going to skip steps and not break anything.
So what I think we're going to do is get this started, and then just kind of, if we have any other final questions, anything you want to say about Calico or whatever, as we kind of let this last print start. We did a print. It's a test print, but the printer is functioning. The build is complete. The configuration is complete. Now tuning time. So.
Always our favorite.
Yeah.
I think I covered about everything that I know of or I'm excited about in Calico.
Awesome. Do we have any questions from the...
There's always stuff in the works behind the scenes. There's some cool features I've been developing very specific to the Cocoa Press that I fully intend to make a more generic solution for and bring mainline in the future. There is a auto calibration for sensorless homing that isn't quite universal at all, but it works on all the machines we've currently tested it on. So I've been working on a few features that are nice for microcontrollers, ways to automatically update the firmware, which are more targeted towards commercially shipped printers where you can just ship a pre-compiled firmware for the Pico that's in them to every machine. But again, I want to genericize some of that so that you can automatically firmware update on your home-built machine. And I'm sure other people are working on things that I'm not aware of because I can't be everywhere at once.
How many people are on the Calico team, on the crew?
I think there's 4 in the crew right now.
Mhm.
And then we have 4 very active contributors that are probably doing more than most of the crew. Um, then there's some side projects people are always working on.
Always.
And people like Morton bringing really cool ideas in.
Mm-hmm. Well, it's like any of these projects, especially when it's all volunteer work, right? It's everything. Yeah. Everything progresses on the flow of motivation and time that the members have, and things really get going when you can somehow beat all the odds and get more than a couple of those lined up.
Looks like kind of relevant to today. Someone's updating the PA test script, adding fan speed parameters.
Oh, okay.
One of my personal projects, more focused towards developers, is using Python packaging infrastructure to distribute plugins. So instead of doing like git checkout and bash script installations, you can just pip install a plugin just like you do everything else. Yes, there's a Phoenix right there. It's definitely not hiding the mess that's behind it, I promise.
Come on. I gotta catch this because I never changed my offset, so I need to go to about 2. There we go. So that is going to run this, and that's probably going to be another. How long did that take on that last one? It was like 40, 45 minutes?
Around there, yeah.
I think we'll just let that go. So any other last second questions from folks in the chat? Is Phoenix helping develop certain features in Calico?
It's either that or I'm developing Calico features for the Phoenix. I'm not sure which direction it's going for the most part. But yes, this one runs Calico. I think there's one other development machine on Calico at the moment. Some of the TMC driver register configuration options that are in Calico were added specifically for me to experiment with some of the 48-volt issues I was seeing.
Is Nexus running Calico? I think it might be.
I think he switched over for that feature, yes. Andrew, AI when for development. At the really high level, it's useful. It's like a junior programmer. If you sit there and babysit it, you can get decent results out of it. But every time I've tried to have it actually do some more advanced development, I end up with completely broken code, and the AI is arguing with me that no, it did it correctly. And when I tell it what it did wrong, it just doubles down, or it tries to delete other chunks of the code to say like, oh, without that, then this would be correct. I think Roger has had some pretty good results in using it for refactoring little bits of the microcontroller code, but I haven't gotten too deep into that.
Need an ice maker mod for your printer.
Just be careful to put it under your electronics bay. You don't really want it on top.
Along the lines of logic and exploring options and rationale.
I haven't used AI that much in development. One of my favorite things I've seen, though, there's a GitHub bot that will use an AI to describe the changes in a pull request and give you like a high-level explanation of what's being changed. And that one has been really useful in other projects I've worked on. We've talked about enabling something like that on the Calico repository.
I wonder how much it could help with documentation.
You have to read it and make sure that it is correct.
Yeah, of course, but outlines and looking for maybe gaps, if there's any.
I've found that just
source that would be helpful for that.
Sometimes I'll go in a function or a chunk of code and just type a comment start and then hit autocomplete and see what comes up. And a lot of the time it's good for that.
Mm-hmm.
And saves me a fair bit of time. I write some code and say, I want unit tests. And it can write a sequence of tests for that code that usually pretty good.
Interesting. Here, we've got some interesting, I think this might be expected as it works through the values.
Yes. And it should be a little different at the beginning and the end right now.
As long as it gets past this without causing some bump and skip steps or something.
If it fails, one of the options, I think, lets you change the starting values.
Ah. Yeah, see, it's bumping over that back corner. Hasn't skipped anything yet, so. But it's obviously way off for the beginning here.
I'm impressed at how far off it is when compared to like the examples of the tests that were being done.
Unless we didn't interpret what it's trying to do correctly. I mean,
well, if you look at the left side, because this is specifically calibrating the difference between the beginning and the end of the pressure advance, the non-linear portion of it.
Mm-hmm.
So when you go back to what's being printed, the left to the center, and then the center to the right side, because it's two movements that are being calibrated here. The far left, and then this little section from the center towards the right, both look terrible. And then the ends of both of those movements are looking a little over extruded, but
I know what's going on.
I
know what's going on. So the default value here is 0.01, not 0.001.
Oh.
The last test was with the default value of 0.01. I wonder if this looks so weird because we were already too far in the degree of correction. Our values were too high to begin with. and now we just looked at the value that looked best, which put us at I think I put it at a 0.44, so that's 0.32. A 0.32 pressure advance value is quite high. It's like Bowden level.
Yeah.
And I think that's actually what's going on, is the defaults that we're in there, that 0.01 is probably where you should be starting with the Bowden. So I think I need to go back and rerun the first test. But where does it say that? Because here you're looking in some of this. In this case, the left side looked best at roughly 0.005. But where did it say to start? If we come up here, Bowden is here. Pressure advance smooth time. But if we go up here to the direct drive, where does it say that we should have started with a different value there?
I only see it having us set the test param and not changing the...
Yeah.
What is that? The range?
It was here. Yeah, PA range. See, 0.01 is the default. So that put us at a 0.352 is what we're running now, which is really high for a pressure advance value, right?
Yeah.
I mean, it's really high for a pressure advance value. Is it really high for linear advance? This is all, J-Dubs, this is all bleeding edge features. So the little bit of leeway on the documentation. And what we're doing here, I mean, Frank is noting where the gaps are. Hopefully it'll incrementally improve.
I'm taking a lot of notes on the side of where we can improve documentation and what seems not quite ready. But that's the point of this branch. These are really experimental features that seem like they're ready to be tested more and seem to have good results, but let's see what happens.
That is definitely in the... I'm not going to continue this for the whole test, obviously. I'm going to go back and rerun the first.
I'm wondering if I did the math and that was off by a scale of 1.
On
like
the
instead
80%?
of on the original 0.44 value.
No, because we were correct. 0.44 is the 0.01 times 44 millimeters, but it should have been 0.001. So it should have been 0.0. We should have had 0.032 here. But we don't know that because we need to actually run that at 0.001 because our scale is wrong. And Andrew, thanks for the gifted memberships, and I saw you had to take off, so have fun on your walk.
It looks like in the macro it should be handling that automatically, but we didn't use the fact. It looks like the first test print was correct.
Was it?
So if the PA value is provided and it's 0 and the test param is 0, it uses the tuning tower with a factor of 0.001.
Where that's in the PA test macro. Let's go here.
In the start PA test, so where it says the factor equals 0.001, 0.01 for Bowden. What we did wrong, I used 0.01 instead of the 0.001 there for the value.
But
when multiplying.
But what are you setting in the macro parameters? So when you go here, it says PA range.
The PA value right above that.
Oh, PA value is...
When that's 0. So I think what we did two things wrong. We want 0.0352 for the PA value there.
Oh, for the next one?
And the one we saved in the configuration.
Okay. Do we have to save it? Can we just enter it here? It looks like we can just enter it here. But this range is still what I'm getting at. Isn't that what the... PA value factor. I don't get it. Hmm?
I'm gonna double check our documentation on this. I think we do want to save it to the configuration.
Okay.
And we provide it in the macro for the test param 1.
Okay.
I don't know if you can cancel print out of this part.
I don't
Be able to.
I really like to... There we go. So I like to pause out of these because I've found that if I just cancel, it doesn't move the tool head out of the way. And I know that's all in the mainsail or fluid default macros, but now we can cancel and everything's reset. That was ugly.
That was horrendous. I'm impressed. It didn't fail though.
It didn't fail. It didn't fail. Okay. At this 5-hour mark, I want to thank you big time for coming on and hanging out with us for most of your day. This was very fun, very educational. This build has been fun, and I will be putting Calico on other printers. I will be doing, the next thing we'll do is putting Calico on an existing clipper install. That one I'm hoping to get Roger on at some point, so I'll line that up when he's not on vacation. But yeah, definitely huge thanks for coming on here. This went a whole lot smoother for you being here. I didn't have to fumble through nearly as much. So if everybody would say thanks, Frank, in chat. We will be back here on Sunday with box turtle stuff. That's the little interim stream before diving into more tool changer things. So Mad Max and Stealth Changer are coming up as series after that. So did you want to say anything? I kind of talked over you a second.
Not much. If you're interested in Calico,
yes,
we have a Discord, calico.gg/discord. The documentation is just at calico.gg, easy to find. And I hope you all enjoyed.
Yes, thank you, everyone. Thanks again. Thank you to Polymaker and LDO for the giveaways. Thanks for all you that stuck around for this 5 hours here. And hope you have a good rest of your weekend, good week. We'll see you next weekend. Take care, everyone. Enjoy the build. Bye.